Good morning, good afternoon, and good evening, everybody. My name is Kartik. I'm one of the co-founders of ETH Global, and I am super excited to welcome all of you to ETHOnline. You're all here watching me on ethglobal.tv, and this is the website and the platform we'll be using for the rest of this month. This is where all the summits and talks are going to be, including the closing ceremonies with the final demos, and of course, all of today. The way this works is that you can sign in on the chat and say hello and talk to us. This is a live stream, so I can read what you're all saying. And we also have an amazing summit right after this, logistics for the hackathon. So if you have any questions for our speakers, you get to ask all of them directly in the chat, and we'll be relaying them to all of our speakers. All right, so to those of you who are joining us for the first time, this event is organized by ETH Global. And for those of you who don't know what ETH Global is, it's an organization with a very simple mission. Our goal is to onboard thousands of developers into the Web3 ecosystem. And we do this primarily by doing two things. We run hackathons and summits. And this month is no different. Talking about summits, these are short 4 to 5 hour days with amazing jam-packed content on relevant topics that let you understand what's happening and the latest that's happening in any given category. And this month is full of that. We're going to be running 5 in total. There's going to be one almost every Friday starting today. We're going to talk about dev tools, how collaborations and DAOs and ETH2 and the ecosystem and everything else is evolving. So check out the website for a lot of those details and the agenda. And for the next 45 minutes or so, our focus is going to be this hackathon. So let's talk about the hackathon. This is not only our biggest event of the year, but our biggest event ever in our history. We were absolutely mind blown with this, the amazing crowd that we have. 1,600 people are hacking for the next few weeks from 96 different countries, spanning 19 different time zones. We also put everybody on a map to see where everybody's joining us from, not only on the live stream, but throughout Discord, email, and all these platforms. And it's astonishing and astounding how much diversity and the span of who's joining from where we're kind of being welcomed from. 6 continents being represented. And I am just so happy to see this. And I can't wait to meet all of you and talk to you all on Discord. And not just the hackers, we also have 35 ecosystem partners and 110 ecosystem mentors that are going to be here with us for the next few weeks, helping you make sure that your projects are successful and you are unblocked on them. And to top it all off, we have $350,000 in prizes that are going to be given away. And we'll talk about what these prizes are, how you can win them, and all the details about receiving them. But before we get into all those details, I want to thank some of our amazing partners who, without their help, we'd not be able to make this hackathon this big and amazing. So I want to quickly thank Optimism, Superfluid, Aave Grand Style, Scale Labs, Polygon, IPFS and Filecoin, WorldCoin, ENS, UMA, Aurora, EPNS, The Graph, Chronos, LivePeer, Vern, ApeWine, Abacus, Unstoppable Domains, Connext, Lens, Spruce, Covalent, Tableland, QuickNote, NFT Port, Valist, dBridge, Teller, Streamer, Sysmo, Oasis, Ceramic, Unlock, and XMTP Labs. So we're going to bring some of them on to talk about why they're excited to be part of this hackathon too. But before we get into all of that, let's quickly cover a lot of the logistics for this month. The goal here is for me to talk about how all these things work, team formation, how you can get help, all the prizes you can win, all the talks and workshops that are happening, altogether how judging and submissions are going to go. We're going to also cover summits and just what's going to be the agenda. And after this logistics ends, we're going to roll directly into our first summit of this month, which is all about DevTools and how you can learn about the latest advancements in building on Web3. So first things first, communication is kind of the most important thing we're going to cover. Everything about this hackathon and this month will be on our Discord. This Discord is only visible and available for attendees who are confirmed and have RSVP'd to hack. and all of our partners. The way you can check this is going according to expectations is you will see an ETHOnline 2022 header on your Discord sidebar. If you do not see that with all these channels, please go back to your Hacker dashboard and see if Discord is connected properly, and that will be your tell. If you are running into any issues connecting Discord, please message anybody on the ETH Global team on any other Discord channel that you see, or by sending us an email, and we'll be able to debug why that connection is or isn't working, or just isn't working. And these are also private channels, so they're only visible to participants, which means that anybody in those channels is also a attendee for this hackathon. So you can also learn where people are from, talk to them, and see what they're excited to build, as well as there are channels for getting help for any protocol that we have on board that's helping us throughout this event, and for any of our partners who are giving away prizes, and also generic help that you can ask in the mentorship help channel. So if you are stuck with anything, whether it's about learning how some documentation works or how some protocol is set up, or just an error that you can't make sense of, just post those questions directly on those channels, and somebody who's actually an expert in those things will be able to answer them to unblock you almost ASAP. On top of that, we're also going to be sending a calendar invites for a lot of the important talks and workshops, and especially for key events like submission deadlines, judging, the finale, and everything in between, including some feedback sessions that we're going to be regularly running, so you can actually understand and get some direct live feedback from some of our partners and mentors. All of this is also going to be reflected on the website, which is the source of truth. Anything that the website says is what we'll be doing. And we really want this thing to be asynchronous. There's about 100 countries that are going to be participating at this event. So we want to make sure that time zones are not a direct barrier. So with the exception of a couple of sessions that are specific to people being on the same call, like team formation, everything will be asynchronous, and you can catch up and keep up with it at your own pace and whenever you'd like. And for those of you who don't know where the website's at, it's online.ethglobal.com. You can head over there to see all the latest details about the hackathon. All right, let's jump into the hackathon itself. So officially, the hackathon has started, which means as of this sentence, you can start working on your projects, and you can work on your projects with up to 5 members on your team. You can also work individually if you'd like, and you can have anywhere from 1 to 5 people on a project. So the max is 5, you cannot exceed that limit, and you are good to start. You have 3 weeks to hack, or 23 days to be precise, and submissions for your hackathons are due at 3 p.m. Eastern on Sunday, September the 25th. That gives you 23 days until the deadline, and the next few weeks are going to be covering stuff around check-ins, stuff around getting feedback, a lot more workshops and talks that you can catch up onto, and going through a lot of the internals about different protocols if you are looking to work on some internal or some really specific protocols that you need more help and time understanding. On top of all of that, we have now a new feature where you can find potential team members who are still looking to join a project on your Hacker dashboard. If you go to your team section, you'll see that you get to opt in to find a team member feature. And anybody who is opt-in, who is officially looking to either pair up or have somebody join their team, can set in their preferences and find other people who are also in that position. There are 1,600 of you, over 1,600 of you joining this hackathon. So there's definitely a lot of you who are still in this position who are looking to find other members to join their team with complementary skill sets. And you can now also use this service in addition to all the calls we're going to be doing and have done to find potential team members. So check this out on your dashboard, and it'll show you everybody who's interested as well. And if it's a match, you get to contact each other directly on Discord. Now let's talk about the rules and the criteria for the hackathon. One of the key things that must be adhered to is that everything that you're going to submit must be done from scratch, which means that you cannot work on a project or a side project that you have been working on already. That also includes adding features to something that you have done that may be entirely new to just this event, but are still being committed to a code repo that was from before this hackathon started. We really want to make sure this is fair and consistent with everybody else's experience. So you cannot build from a pre-existing personal projects. If we find out that this has been the case, that team will be disqualified from this event and no prizes will be given to the team. And a really, really important note is that only RSVP hackers are eligible to win prizes. That means if you are working with a team and each of those team members has not RSVP'd and confirmed as a hacker, and they do not show up on the team section on your project and your dashboard itself, if you win any prizes, we will not be giving prizes to anybody that was not listed on the team. So it's your final kind of call to make sure that you ping everybody who was on your team to verify, confirm, and have them show up as a team member on your dashboard. And if you have any questions about these things, let us know. You can ping anybody on the team on Discord or over email, and we'll be happy to answer those questions for you. Let's talk about judging. So submissions are due on Sunday, the 25th at 3 p.m. And the way judging is set up is that there are two parallel tracks. There's going to be a main judging that is going to be a synchronous session. This is one of the only key times where everybody must be on an actual call independent of the time zone. And that's going to be from 12 p.m. to 2:30 p.m. Eastern on Monday, the 26th. And then for anybody going for partner prizes, there's going to be an asynchronous track where all of you who are trying to go for a prize, those projects will be sent to each of our partners and they'll be reviewing everything on their own asynchronously. And if they have any questions for those teams, they will be pinging you directly on Discord or email, clarifying anything that they'd like to know before they decide who is going to be the ultimate winner for each of those prizes. But I want to focus a little bit more on the main judging. The main judging is going to be a synchronous call, which means that everybody as a team comes on and demos what they built. Each team will get 4 minutes to do a demo of what they prepared. So make sure you are concise in really communicating what you are doing and what you have done over the past 3 weeks. And this will be a video submission only, which means for your demo and your submissions on the Sunday, the day before judging starts, you are required to upload a 4-minute video or max 4-minute video talking about what you built with a demo, team, any other additional information. And that's what you are going to be showing to our judges. And we see this all the time, but we really recommend that you do not do this last minute because this will take a lot of time in making sure it's concise and it fits in the 4-minute limit. All these details are going to be available and visible to you on your dashboard as we get closer to the submission deadline. And we'll be sharing a lot more of these specifics, but you can also get a quick peek at what this process looks like by heading over to your ETHOnline Info Center. And that we'll talk about the judging and submission process altogether. And you can also see some sample previous submissions about really projects that we like on the submission formats. And you can use that as a reference and really prepare an amazing demo for the judging. So all this is on the dashboard. We're just giving you a heads up here. And all these things will become more and more common and communicated really well in more specific details over the next 2 weeks. And of course, we recognize that there's a lot of you who are trying to get into Web3 and are trying to explore what's possible. So don't worry, this event is designed to be beginner friendly. And that is why we have so much focus on amazing talks and workshops and the summits. And all these things are ensured to really satisfy every type of skill sets, whether you're a beginner or an expert. And this is also the reason why if you are feeling like you are too overwhelmed that you're not able to understand everything that's happening or you want to catch up more, you can just tune into the summits as an outsider too. Everything is going to be live streamed and public and open, and summits are happening every Friday. And for the hackers specifically, all the details around from submissions to any rules and edge cases to logistics around the next the entire month of September will be listed on your info center, including any frequently asked questions. And the most common question we get and want to address is, yes, everything is going to be recorded. So if you're not seeing this live right now on ethglobal.tv, the same video will be available on our YouTube immediately after this live stream ends. And you can just head over to youtube.com/ethglobal or just go directly to the website, online.ethglobal.com, to click on the schedule item itself and see the video recording of that event. We'll make sure it's really accessible to everybody, and these things will be there for all of you to catch up at your own pace. So no need to prioritize something else over this. If you have other obligations, focus on making sure you are able to catch up when you'd like. All right, now let's get into some of the fun stuff, which is some of our partners who want to talk about why they're excited to be part of this event and all the prizes. And after that, we will get into talking about all the summit details and kick off with our DevTool Summit. So first up, I'd like to invite Kelvin from Optimism to share why he's excited to be part of ETHOnline.
And now, our feature presentation.
It's me, the very serious person named Kelvin. And today, I'm talking to you about the only serious blockchain called Optimism.
This is a very serious situation, and they need to take certain steps to protect themselves.
If you're building on Optimism, you better only build serious applications. You know how serious I am. Look at this. Optimist. Oh, yeah, that's right. So, why should you build on Optimism? Because we are solving the public goods funding problem. Why are we solving the public goods funding problem? Because it turns out the whole point of everything that we've been doing for years has been to make actual widespread societal impact. With the work that we've been doing, it's not just to take the yam and to put the yam in the cup, and then somehow, because you put the yam in the cup with the ETH, it turns into 2 yams, and then you take the second yam and you put it and you leverage it and you turn it into ST ETH somehow, and you put it in the bean pot, and the bean pot gives you more yams. People are doing this with the yams and the bean pots. It doesn't make any sense.
There's no Pepe Silvia. You gotta be kidding me. I got boxes full of Pepe.
But you know what we could be doing instead is having a real societal impact. So Optimism, we made a blockchain, right? Because we realized, you gotta scale this stuff. Sorry, you gotta scale this stuff. And then we were like, wait a minute. Actually, what we're trying to achieve is to use this software that we've constructed in these crypto economic frameworks that we've constructed to achieve something. In this case, we believe that we can create a better funding model for public goods, and we start by focusing on open source software because that's what we know. So I'm just saying, build on Optimism.
Break it.
You think they like that stuff? This guy.
That was the amazing Kelvin talking about Optimism. As a note, I had not seen that video before this thing because I was told that I need to react to this live, and it is incredible. So You also get to see what Optimism is doing for prizes, but hopefully you get a better glimpse into what Optimism is from those last 2 minutes, a very serious blockchain. All right, up next is Fran from Superfluid, and he's going to talk about streaming money.
I'm Fran, one of the founders of Superfluid, and I'm super excited to welcome you all to ETHOnline this year. This, I think, is the second time we sponsor ETHOnline, and at Superfluid, we love hackathons. We've seen some amazing projects come out from last year, and we're very excited to see what you get up to and what you hack over this month. What we do at Superfluid is digitally native programmable cash flows. Using Superfluid, you can send streams of money without needing to lock up the capital up front and with full programmability, which means you can let your mind loose and build some crazy stuff. So what does money streaming mean? So these are basically open-ended transfer of funds. You set up a stream and it goes every second, it keeps moving money. It's fully liquid, the recipient can spend the money as they get it, and you can collateralize your stream as you go. By doing this, the recipient gets paid every second. There's no delays. They never risk not getting paid because they're getting paid every second. And there are no intermediaries, right? It's web-free, it's completely on-chain, fully permissionless, and anybody can use it. So basically, you can imagine with Superfluid, we're switching up a bit the way you pay, right? Instead of paying at the end of a period, you basically get paid throughout the period, right? So the way we like talking about it is that we're moving from recurring payments to ongoing streams, right? This is the web-free native way. So what can you do with it? You can do subscriptions, you can do salaries, you can do social tokens, right? Maybe you're paying your community a reward for joining your Discord. You can build some interesting DeFi products, and of course, a lot of games, right? Imagine a game that sends you their own in-game currency as long as you're playing it. So how do you get started? Well, the first thing, you can go to our dashboard, that's app.superfluid.finance, and here you can start experiencing what money streams are like. As a developer, we also have an amazing tool called the console, which will allow you to visualize what other people are doing. You can see your contract address, and you can start exploring the subgraph as well. Building with Superfluid, you'll find a lot of interesting and useful tools. We've got SDKs in JavaScript and TypeScript, Subgraph, Solidity libraries, example applications, and a list of interesting hack ideas for you to get started, getting your brainstorming session going. But if not, we have also a Discord channel where we have a lot of ideas going all the time. If your experience at the hackathon is great, after the hackathon, we would love you to join the Superfluid Reactor. This is basically an acceleration program where we will take you from your prototype to getting ready to raise funds or go live in production. It's a completely free program that we run only with the best teams out of hackathons. So when you're building at a hackathon, don't think about it as a prototype. Think about it as your first step into Web3 and into building an amazing project. So yeah, welcome everyone. It's a month long, and please come and hack on Superfluid.
Awesome. That was Fran on Superfluid, and we'll talk about all the Superfluid prizes very soon. And next up, we have Jess from Aave Grant Style.
Hi everyone, my name's Jess. I'm the Developer Relations Engineer at Aave. If you haven't heard of Aave, it's a decentralized liquidity protocol where you can supply and borrow different cryptographic assets. Aave is one of the largest and most exciting DeFi protocols, and it's deployed across a number of different chains. We're so excited to be participating in ETHOnline, and Aave Grant Style are offering $20,000 worth of prizes for you to integrate with and build on top of the Aave protocol. You must build a project relating to one or more of the prize categories, and for each category, you could win $3,000 for first place and $1,000 for second place. We have 5 prize categories. For the first category, we're looking for projects and integrations that can bring more stablecoin liquidity into Aave. The second category uses the Lens protocol to assess the reputation of profiles for credit delegation. And the third category looks at accessibility. Think about what new ways could help users to access the Aave protocol. The fourth category is an Aave Forex tool. Can you help users to access Forex liquidity using features like flash loans or DeFi integrations? And finally, the fifth category is to create new ways to compose or visualize Aave transactions. We as a team are here to support you, as well as the Aave Grant Style. So please do reach out to us on Discord and let us know what you're building on Twitter and Lens. Thank you so much, and we can't wait to see what you build.
Thank you, Jess. And next up, we have Connor from Scale.
Hello, welcome to ETHOnline 2022. My name is Connor Murphy, and I run business development at Scale Labs. Scale Labs is the core team bootstrapping and shepherding the Scale network. Now, Scale Network was purposely built to bring Ethereum to billions of users by providing them zero gas fees. And Scale is able to achieve this through its transformative multi-chain approach. Through this approach, and leveraging Ethereum's base layer of security, developers finally have a high-performant blockchain with instant finality and, once again, zero gas fees. Now, what is this exactly solving? Well, currently across the industry, many blockchains are monolithic or just single databases. And as demand increases, we see a squeeze on supply. And as many of us saw over the last couple of years, users have to deal with this squeeze, either through increased gas fees, slow blockchains, or even worse, the blockchain crashing. Monolithic blockchains just can't solve this supply-demand equation. And this is where Scale steps in. These monolithic blockchains are realizing that they can't solve it by being a single database, and they need to pivot to being multi-chain. Well, Scale's been multi-chain since inception. And as demand increases, more nodes enter the network, and Scale is able to limitlessly add more supply. This allows for a ton of gas fee savings. And Scale is building for a future of mass adoption, one where we use blockchains every day through gaming, DeFi, Web3, and more. And unfortunately, with the gas fees that we saw over the past year, this just isn't possible. We would never be able to hit the scale we want to hit with users paying these gas fees. And this is why we built Scale. Scale's V2 launched this past July, and we've already seen massive growth. We're working with new dApps every day and working to save end users millions upon millions of dollars. We'd love to have you join the Scaleverse. Please find our documentation here or reach out to any of the core team members on Discord or Twitter.
Awesome. Next up, we have Polygon.
Hello, everyone. This is Sandeepan from the Polygon Dev team, and we are very excited to partner up with ETH Global for the flagship online hackathon, ETHOnline. To give you a little bit about context about Polygon, Polygon is a smooth solution of Ethereum scalability. It's blazing fast, it's secure, it's decentralized. The problem statement that Polygon solves is that no size fits it all, like different use cases are being built out at Polygon with ZK and other types of optimistic rollups coming up in the future. And there is also no formalized framework. That's when the Polygon solution comes in with a Swiss Army knife for Ethereum scalability with ZK rollups, optimistic rollups, enterprise related chains, security chains, and definitely the beloved plasma chain. So building on Polygon is like developers love building on Polygon, and hope you have an excellent time this time in this hackathon also. The backward compatibility, Polygon is Ethereum EVM compatible. You can use all the tools and infrastructure you already love. You don't need to learn anything new. For this hackathon, we are giving out 20K in prizes, and there are main 3 tracks. The general track is like first prize will go $5,000, second prize $3,000, third prize $2,000. There's also a best innovative dApp built on Polygon. So like we always see a generic kind of dApps built on. So, but what can be a unique use case? If you can think about in that case, then there's a $3,000 prize for that track. And then definitely some of the unique projects being built on Polygon will be awarded with the pool prize, and 7 winners will be selected, $1,000 each. Thanks a lot, everyone. I hope you guys have a great time building in the hackathon.
Amazing. That was Sandeepan from Polygon. And our last one is going to be Nikki from IPFS and Filecoin. And Nikki will be joining us live. So please welcome Nikki to share about why they're excited to partner with ETHOnline.
Hi, everyone. My name is Nikki, and I work on developer onboarding initiatives at Filecoin. I'm very excited to be here to wish you all good luck for ETHOnline 2022. Hackathons are a great place to experiment and get your hands dirty and build projects. And who knows, someday, some of them might also turn into $1 million fundraising companies. I represent IPFS and Filecoin, and as most of you know, we are on a mission to decentralize the internet and by extension, decentralized storage. While our challenge statement is the best use of NFT storage or Web3 storage to use IPFS for content addressing and Filecoin for persistent decentralized storage, it is kind of broad to encourage any and all ideas that might come out of this hackathon. However, here's a tip. We would love to see some dev tooling solutions that can help other developers easily use IPFS or Filecoin, or projects that are Web3 versions of Web2 apps that are an essential part of our lives today. The question we are really looking to answer is, how do we solve problems that come in the way to really scale and help apps and users move to decentralized storage? I hope that inspires you. We have $20,000 in total in bounties to give away for you to use IPFS and Filecoin in your projects. We do have a pool prize as well for up to 25 teams in addition to top 3 prizes. We'll share all of these details on Discord, and our dev advocates will be there to answer any questions you have or help with difficulties you run into. We'll be here to encourage you even after the hackathon. So please think of this as a first step and with our grants and accelerator program. And so don't be discouraged if you don't win in this one. Good luck and happy hacking. Thanks, Karthik. Thanks, Jacob.
Thanks, Nikki. That was awesome. And you can also check out all these things on your hacker dashboard now. All right. So before we go into all the other prizes and all the specifics of a prize, I want to give a quick reminder about how check-ins work. And you may have seen this on your dashboard and on the info center, but it's a very simple thing. We're going to do check-ins every week. This is a way for us to kind of quickly see how things are going and make sure that you are not stuck. And if you are stuck, you're getting any help getting unblocked, whether it's on the code side or anything else. And it really kind of helps us make sure that you are able to really accomplish your goals and continue to get to the end product of what you are excited to build. And your stakes are also tied to this thing. So checking also helps you get to the path of making sure you are satisfying participating at the hackathon. All this thing happens over your dashboard. So the way these things are set up is that every check-in will start appearing on your dashboard early every week. And you'll also be notified of these things. So don't worry if you don't see anything now, because they are not going to be visible. They will start showing up early next week as a simple form that just says how things are going and if you need any help. So keep in mind that those things are going on, and they also help you really prep for any of the feedback sessions we'll be hosting. So you can come on to those feedback sessions and ask any of our mentors or our partners for advice, help, direct support, kind of like office hours, and really see what everybody else is building as well. And all that is tied all together as part of the next 3 weeks. All right, let's go into all of the prizes. You kind of did get a sneak preview of some of these things, but I'll still go into a lot more detail about every partner that is giving out a prize. We're going to start off with the Aave Grand Style. Lots of prizes being given away. That is about $20,000 of prizes from the Aave Grants team, and they are separated by different categories. So if you are building any project that covers the stablecoin and growth category, you will be able to receive $3,000 for the first place and $1,000 for the second runner-up place. Any Aave related hack that tackles credit delegation will be receiving $3,000 for the first place and $1,000 for runner-up. Any project on the Aave protocol that addresses accessibility will be receiving $3,000 for the first place and $1,000 for second. Any Aave integration that covers Forex and applications around that category will be receiving $3,000 for the first place and $2,000 for the second. And any Aave transaction builder related hack will be receiving $3,000 for the first place and $1,000 for runner-up. Then we have the IPFS and Filecoin prizes. So a lot of prizes being given away as well from the IPFS teams. They're going to categorize them as Storage Wizard prizes. So the best integrations on IPFS Filecoin network related projects will be receiving, best 3 integrations will be receiving $3,000 each denominated in Filecoin tokens. And there's also a pool price category, which means that up to 25 teams will be splitting $11,000 amongst themselves, delivered in Filecoin tokens as well. So that means a lot of people can potentially qualify, and there's up to 28 teams that can win prizes from the IPFS Filecoin team. Then you have Polygon. Polygon is giving prizes in a lot of different categories. So to scale your applications on Polygon as the qualifier, you will be receiving $5,000 for the first place, $2,000 for $3,000 for the second place, and $2,000 for the third place. And the most innovative dApp and dApps built on Polygon will be receiving $3,000 for kind of being the best app from all the submissions. And then there's going to be 7 runner-up prizes, where the top 7 teams that are leveraging the Polygon ecosystem and deploying on Polygon will be receiving $1,000 each. Next up, we have Superfluid. So Superfluid is also giving lots of prizes. I think that is 20,000 in total. The best overall hack that uses a Superfluid streaming protocol will be receiving $4,000. The best hack that specifically covers DeFi will be receiving $3,000. The best streaming payments project that is around making streaming work for DAOs will be receiving $3,000. The best gaming related streaming money hack will be receiving $3,000 as well. And the best futuristic hack around super interesting futuristic use cases of streaming money will be receiving $3,000 too. And they also have a $4,000 pool prize, which means that any other team that is building on Superfluid, as long as they are making a good and sufficient use case of the protocol, will be splitting $4,000 each among themselves. Next up, we have WorldCoin. So WorldCoin is giving a lot of prizes as well. The best overall project on top of WorldCoin will be receiving $4,000. The best governance app that leverages the WorldCoin SDK for proof of personhood protocol will be receiving $3,000. The best social app leveraging the WorldCoin SDK will be receiving $3,000. The most creative use case of WorldCoin proof of personhood protocol will be receiving $3,000. And there'll also be 4 runner-up honorable mention prizes, each receiving $1,000 each, and a pool prize category, which means that any teams that are building on top of WorldCoin will be splitting $3,000 evenly amongst themselves. Then we have the very serious prizes from Optimism. The best NFT infrastructure will be receiving $5,000 for the first place, and there'll be 2 runner-ups for $2,500 each. The best games being deployed on Optimism will be receiving $2,500, and up to 2 teams will be the recipients. And there will be 2 $2,500 prizes for the best community infrastructure project on top of Optimism. And then there'll be 10 prizes for $250 each to the 10 next best teams building cool Optimism deployment hacks and leveraging the Optimism ecosystem. Next up, we have Scale. For the best use of Scale, and the grand prize will be $5,000 in Scale tokens. The best project that leverages Scale and is on around building projects around metaverse gaming or NFTs as a category will be receiving $8,000 in Scale tokens, and this will be split between those multiple projects, not just a single category. The best partner integration will be receiving $2,000 in SKL tokens. And there's also going to be a $5,000 pool prize for Scale, which means that any other team that makes a sufficiently good use case of the Scale SDK will be splitting $5,000 evenly. Then we have EPNS, and EPNS is giving a lot of prizes for the best integrations of the notification API and any wallet that leverages the communication services that EPNS offers. So the best use of EPNS will receive $4,000 for the first place, $2,500 for second, and $1,500 for the third place. And there's going to be 5 runner-ups receiving $400 each. Next up, we have AP Wine. ETHOnline is categorizing the prizes in 2 categories. For the wine connoisseur, they'll be receiving $5,000 in APW tokens for the best integrations, and then also runner-ups for $2,500, two places for the best integration of the yield tokenization integrations into your DeFi-related hacks, and $2,500 will be split given to 2 teams individually, so additional $5,000 in second place runner-up prizes. Then we have Aurora. And Aurora is a bridge between Ethereum and Near. So the best integrations and use of Aurora will be receiving $5,000. The second place integration for Aurora will be receiving $3,000, and the third place will be $2,000. Next up, we have Yearn Finance, and the best integrations leveraging the Yearn protocol will be receiving $5,000 for the first place, $3,000 for the second place, and $2,000 for the third place. So any hack that is in the DeFi category and is doing aggregation and composability around yield strategies is qualified to win $10,000 in total here. Next up, we have ENS. ENS is the Ethereum name service, and they have a lot of interesting categories that talk about you being able to win a lot of prizes for using ENS in a really interesting way. So for the platinum category, you have $3,000 for the best ENS integration for the Obelisk 2000, for Bob 2000, Fried X 1500, and the Nick category will be 1500. And the specifics of each of these categories are also going to be available on the prize page. So you can check out the exact details on your dashboard or on the prize page, which I'll talk about in a second. Next up, we have Kronos. So Kronos is an EVM compatible layer built on Tendermint and the Cosmos SDK. So the best use of Kronos will be receiving $2,000. The top 5 integrations will be receiving $2,000 each if you're interested in checking Kronos out. Then we have Abacus, and Abacus is an interchain messaging API between different blockchains. And the best use of Abacus will be receiving $4,000 in prizes. The best use of Abacus that is building a DeFi specific hack will be receiving $2,000. And the best Abacus integration that's in the NFT category will be receiving $2,000 as well. And any infrastructure for interchain and cross-chain use cases leveraging the Abacus SDK will be receiving $2,000. Next up, we have LivePeer. So the best use of LivePeer will be receiving $5,000 for the first place, $3,000 for the second place, and $2,000 for the third place. And LivePeer lets you do decentralized live streaming and any creative hacks around live streaming over decentralized networks. And doing this in Web3 is an excellent use case for you to integrate the LivePeer protocol and SDK. Then we have UMA. UMA is a decentralized financial contracts platform letting you build a lot of really interesting DeFi applications, especially through their optimistic Oracle SDK. So the best use of UMA's optimistic Oracle integration will receive $5,000 for the first place, $2,000 for the second, and $1,000 for the third place. Next up, we have Unstoppable Domains. So the best use of login with Unstoppable Domains will be receiving $1,500 for the first place and an additional $1,000 free domain credits for you to, in a way, scoop up a lot of interesting domains with a lot of different Web3 specific native TLDs. The second place goes to $1,000 and $750 in free domain credits. And the third place will be receiving $700 for the best integration and then $500 of free domain credits. They also have a prize pool of $1,800, which means that any teams qualifying to meet the proper integration use cases will be receiving and splitting $1,800 and also $300 in domain credits. Then we have Covalent. And the best use of Covalent, which is a single API for querying the blockchain around all the data that you're looking to get across different networks, will be receiving Pool price categories only, which means that all covalent integrations that are sufficiently utilized and integrated will be splitting $5,000 equally, and they're divided into 3 chances of reward levels. So you'll get to learn the details around that on the price page. Next up, we have Lens. And for Lens, we have 2 categories, or one category and 2 prizes. So the category is going to be around any apps that help you enable publishing faster and making that experience better. So the first place will receive $3,500, and second place will be getting $1,500 for the best use of Lens into their hacks around publishing. Then we have Spruce. So for Spruce, Spruce lets you control all of your data across the web, especially through their primitive signing with Ethereum. So the best use of signing in with Ethereum as an integration will receive $1,000 for the first place and 2 $500 prizes for the runner-ups integrating signing with Ethereum. And you also get to learn a lot about this in our DevTools Summit, especially using tools like WogMe and Ethers, whom are going to be covering what's next for those protocols and those SDKs. And then any contribution that helps make the signing with Ethereum library and SDK itself better will be receiving $1,000 for making commitments to a really amazing open source initiative. Next up, we have Connext. And the best original project built on top of Connext will be receiving $2,000, which is any interesting use case that helps you call contracts between different L2s and enable for a new, more efficient cross-chain communication. And the best cross-chain augmentation of an existing protocol, which is integrating with an existing protocol that previously wasn't as integrated with any cross-chain use cases, will receive $2,000 as well. And then there's also a pool prize of $1,000 for anybody who makes a successful cross-call. Next up, we have the Graph. The Graph is an indexing protocol letting you query all blockchain data efficiently through GraphQL. So they have 2 categories: the best use of an existing subgraph in your projects from their Graph Explorer page. The first prize will be going to will be for $1,700 to the best integration that using this subgraph, and a second runner-up prize for $800. And then you also get to contribute subgraphs to the Graph Explorer and ecosystem. And the first prize there is also going to be $1,700. And then the second best new subgraph contributed to the Graph Explorer will be receiving $800. Then we have NFT Port. NFT Port is the Stripe of NFT. So you can get all the infrastructure requirements for being able to essentially do anything you like to do around buying and managing and selling of NFTs. And they're also doing a pool prize of $5,000, which means all NFT Port integrations will be splitting $5,000 equally. Then we have Tableland. And Tableland is a decentralized database network. So if you want to have the ability to query information on-chain writing SQL, Tableland is what you want to try out. That's a really interesting tool. And the most innovative use of Tableland in a project, especially integrating a decentralized database, a relational database, will be receiving $1,000 for the first place, and the runner-up will be receiving $500. And there's also a pool prize, which means all projects that use Tableland in a really interesting way will be splitting $3,500 equally. Then we have QuickNode. The best use of QuickNode's NFT or token API will be receiving $2,500 for the first place, $1,500 for the second place, and $1,000 for the third place. And QuickNode is a service that lets you really efficiently get on-chain data, whether it's to our RPC or through really specific endpoints that help you aggregate and make sense of NFT and different tokens directly. Then we have Sysmo. Sysmo is a really interesting tool which lets you generate ZK badges, proving reputation identity without actually compromising on privacy or sharing information. So they have a lot of different categories. For the privacy fighter category, which means the best use of Sysmo to help people improve their privacy, will be receiving $2,000. There's a Sybil killer category. So the best Sybil resistant ZK badge will be receiving $1,500. And the best ZK badge altogether, which is a badge that you mint through the Sysmo SDK, will be receiving $1,500. Then you have dBridge, and dBridge is a generic cross-chain interoperability protocol, and the most innovative cross-chain applications using dBridge will be receiving $2,500 for the first place, $1,500 for second, and $1,000 for third place. Just a couple more to go, and then we're going to kick off with our DevTools Summit. So really appreciate everybody checking out all these prizes. If you have any questions about the event or the logistics, feel free to ask them on ethglobal.tv's chat. So next up, we have Ceramic. Ceramic lets you access data in a really composable way that's native to Web3. So the most innovative application for data composability discovery will be receiving $3,000 for the Ceramic SDK integration. The best integration of ComposeDB as a database layer for their hack will be receiving $1,500, and the best use and integration of ComposeDB with another partner of ours as an integration will receive $500 for encouraging a lot more collaboration. Then we have Teller, and Teller is an Oracle protocol. So there's going to be $5,000 for a pool price category, which means all integrations of Teller will be splitting $5,000 amongst themselves. Then we have Unlock, and Unlock is a protocol to let you manage and create memberships leveraging different NFTs and standards and access controls. So the most inventive use cases that create Unlock integrations and introduce memberships will be receiving $2,000 for the first place, $1,500 for second, and $500 for third place. Then you have Oasis Network, and the best use of Oasis will be receiving $5,000 for their integration. And then you have Auth Protocol, and it is a protocol that helps you really manage how to efficiently create and manage DAOs. So the best DAO-powered dApp with the protocol and the SDK will be receiving $5,000. And then we have XMTP Labs. XMTP Labs is a way to create secure messaging between Ethereum accounts. So the best use of XMTP will be receiving $2,500 for the first place, $1,500 for second, and $1,000 for the third place. And there's going to be a pool prize where every qualified entry will be receiving $100 each for the best use of Powered by XMTP into their applications. And then we have Streamer, and Streamer lets you create really interesting pub/sub use cases for faster P2P messaging. So the best use of Streamer will be receiving $2,500 for the first place, $1,500 for second, and $1,000 for the third place. And then Ballast. So Ballast is a Web3 software distribution platform, and the three best projects published using their SDK or who self-license their NFTs or other use cases using the Ballast protocol will be receiving $1,000 each and a pool prize of $2,000. So all interesting Ballast integrations will be splitting $2,000 evenly. So there was a lot of prizes because we do have $350,000 in prizes from everybody. So you can check out all those details on online.ethglobal.com/prizes. That'll get you all the specifics, documentations, workshops, talks, examples of every protocol that's here giving a prize. And you can also see that on your hacker dashboard. So before we kick off the summit, I want to make sure that we make a really quick note, which is this is a month-long event. We specifically designed it to be this long, so all of you, especially beginners, get to really take the time to learn and understand before you dive into how things are interesting and exciting in Web3. So please pace yourself. We really don't want this thing to be exhausting for you. We really want you to have fun building and learning about what's possible here. And this whole month and event is about experimentation. It is okay if you don't get to finish everything that you wanted to do, but as long as you end up learning more than you did today or the week before, that's our goal, and that's kind of our hope. So please don't hesitate to ping anybody on Discord if you need any help, if you want to understand some topic better, or if you have a bug that you can't figure out why it's happening. We are there to make sure that you are able to learn and move forward. All right, with that, happy hacking to everybody. As a hacker who joined in, we'll see all of you on our Discord. And with that, we are ready to roll off with our DevTools Summit. So for those of you who are joining us, this is ETHOnline, a month-long event focusing on all the amazing things happening on the Ethereum ecosystem. We're going to do a summit every week on a topic that is going to be relevant to what's happening in this space of Web3. And we're going to start today and this whole hackathon focusing on dev tools and how you can use different dev tools and SDKs and what's coming in, anywhere from best practices to feature requests being handled to future versions and what they're going to support for all the libraries that you already use. From Solidity to Ethers, everything will be covered in the next few hours. So a jam-packed next few hours for all of you. We're going to kick off with Adam, who's going to talk about hard hat and anywhere from best practices to tips and tricks that you didn't know. Then we have Taz talking about the Solidity best practices, and we're going to cover 10 tips for how to be a better Solidity developer. And then Garrett is going to talk about how you can actually use Viper to build secure and faster DeFi apps. Khan will be talking about how to use Sourcify for verifying and checking your smart contracts for potential security risks. Hari is going to talk about what is happening with the Solidity language and the latest with everything that they're thinking about at the Ethereum Foundation on the Solidity team. Tom is the author of WAGMI, which I'm sure all of you have used at this point, and Tom's going to talk about some of the internals around WAGMI and what's coming next. And we're going to end the day off with Rick Moo talking about the next big release of Ethers.js with what's coming in Ethers v6. All right, enough of me talking and intros. I want to kick us off with our first summit talk of the day, and that is Adam talking about having fun with hard hat. So without further ado, let's welcome Adam on stage. Hey, Adam.
Hey, how's it going?
Going great. I'll let you kick this off, and welcome.
Cool, thanks so much. Cool to be here. All right, so I guess let me share my screen. So today we're talking about having having fun with hard hat. So I guess I preface this by saying that this is not a sort of walkthrough of how to build an app specifically with hard hat. There are loads of really great guides out there that'll show you just that and show you how to build like all manner of apps. Here today, I really wanted, I guess, dig into hard hat, give a bit of an overview of what it is, the toolkit, and then I guess run through some of the cool stuff that you can do with it. So I guess we're going to go gradually up the meme. So we're going to start, obviously, talk about some of the basics, local EVM, compiling contracts, deploying them. We'll talk a little bit about testing and some of the cool plugins that you can leverage if you're using hard hat, and then some other stuff around like custom tasks, EVM manipulation, forking chains, and contract verification. So a whole bunch of stuff. We're going to obviously try and do stuff live. And so we'll see how that goes. But that's how we're kicking things off. I guess just to really like orient and level set. Yes, I'm a I guess Web3 developer, worked on a bunch of stuff. I'm going to be working with Scaffold ETH. That was how I got into the space, and I know loads of folks came that same way. Doing a bunch of work with Austin. So I've worked on Nifty Inc., which was built with what was formerly known as Bwidler, and now is then became Hard Hat. So I've been using Hard Hat for a while. It's been cool to see the tool set develop, and I'm currently a PM working on the graph. And so hopefully, if there's time, also pull in a work in progress Hard Hat plugin, which is making it easier to develop subgraphs as well. So bunch of context there. As I said, we're going to start at the top. So a Hard Hat is first and foremost, there's the Hard Hat network. So it's basically a local Ethereum node that lets you do development and be debugging. So that's super cool. In terms of getting started, there's really good documentation. I'd encourage folks to jump into that. It's actually been revitalized quite recently, also with the organization. So Hard Hat used to just be pretty agnostic. It had essentially the EVM, a bunch of stuff that you could do with it, and then a really diverse set of plugins. But more recently, they've introduced the Hard Hat Toolbox, which is a sort of bundled, commonly used set of packages and Hard Hat plugins that they use to get started. So one thing I did in sort of preparing for this was that I updated Scaffold ETH to use the latest version of Hard Hat, and I've also pulled over to to start using the toolbox. So we'll run through all of that today. So if I've got I'll share the whole screen, if it'll let me. Yeah, perfect. All right, hopefully you can see the whole screen now. Maybe, well, yeah. Cool, perfect. So yes, as I said, I'm in Scaffold ETH. We're going to run through a bunch of things today. Within Hard Hat, just to orient folks, there's again great content online on getting it installed, but the heart of Hardhat in any place is the Hardhat config file. So essentially, this is a configuration file where you say, okay, when you're running Hardhat, here are the things that I want to pull in. Here are the things I want to use. So one of the first things that you'll almost always do when you're working with Hardhat is you'll run a local chain. So essentially, if I'm running this, here I'm running a Hardhat chain. And what does that mean? It's basically running a little Ethereum virtual machine on my laptop, which I can deploy contracts to. So maybe we'll start with that. And if I run yarn deploy, we'll see a bunch of stuff happening. Essentially, to orient folks, I'm in this Hardhat directory. I've got my Hardhat configuration file, which, as I said, has a bunch of stuff, which we'll talk a little bit about that in a second. Then we've got my smart contract in here in the contracts folder. So this is a super simple, this comes with scaffold ETH, but it's a super simple contract which lets you set purposes. So this one doesn't let you do much apart from set a new purpose, and it emits an event whenever that purpose is set. So what I did was I spun up that local chain. So you see this chain running, and then I essentially deployed. So actually, if I deploy to that network, localhost. So if I deploy to this network, fantastic, good start. Let's see. Seems to have deployed. So now if I run back, and now if I actually run a local app just so we can interrogate and see some stuff that's going on, we can get a sense. And this is, yeah, as I said, using the scaffold ETH framework, but we're going to really dig into some of the stuff that you can do with Hardhat. So essentially, if we look at this this contract, and if we pull it out here, if we go to the Hardhat config, just to orient people to some stuff that's going on in here. So firstly, Hardhat has this really cool plugin-based model where you can pull in plugins which others have developed or that the Hardhat team have developed, which are relevant and interesting. So one example is so that's called the localhost. So one example of a plugin which is imported here is the Tenderly plugin that lets you leverage loads of stuff that the Tenderly team can do, everything from interrogating local transactions to verifying your contracts. The Hardhat toolbox I kind of talked about earlier, and the Hardhat deploy plugin is a really great community-based plugin from Wigglewag, which essentially lets you manage all your deployments. So just to dig into that a little bit more, deployment in Hardhat can be done in a bunch of ways, but this Hardhat deploy plugin is really great because it gives you lots and lots of control when you're deploying your contracts. So to orient you in terms of what happens here, if we go into this deploy folder, which is how Hardhat deploy works, it'll essentially run all of these deployments. So this is deploying your contract. So when you run Hardhat deploy, it'll essentially run through these and run all of these, run all of these migrations. So this first deployment of your contract is essentially getting deployed here. It's then getting deployed, and there's a bunch of other stuff here which shows you some of the power of what you can do with Hardhat, but it's pretty simple to start with. So if we jump back to the front end, debug contracts, we can see this first one in here. So that doesn't seem to have worked nicely. Okay, now, perfect. Okay, this is good, always good. Live demo stuff. Okay. Let's go up here, 545. Cool. Let's see if we can fix this. Cool. See if that's kind of working. Actually, maybe we will see if that deployed. Okay, I know what this is. Okay, classic node compatibility and then use. Okay. Perfect. Okay, perfect. That's we're off and we're rolling. All is well now. So if we now go back to the local host, we can see this contract. So we're building Unstoppable Labs. And now if I call this contract, firstly, if I grab some funds from the faucet. So one really great thing about a local chain, which you're running, is that you can pretty much do whatever you want. So here I initiated a little transaction to myself, sending myself some ETH so I can actually start transacting. So testing with Hardhat. Okay, if I send that, fantastic. You can see I'm making this transaction. I set the purpose, and then you can see that the purpose is now updated. So I'm interacting with a local chain. So then one cool thing that often when you're working with Hardhat is you'll be debugging your smart contracts. A cool thing which you can do, which you can't do with a normal chain, is essentially console logging. So that classic thing that you want to do essentially when you are you may be debugging a contract. So Hardhat have a special console.log, console.sol contract which you can import into your contract, so you can start to do some debugging. Maybe not so relevant to this, like in this super simple case, but it might be that you want to test why a certain logic branch isn't being passed down, and so console logging from within your contract will let you do that. So to keep moving forwards, I'll save this, I'll redeploy my contract. So essentially, it gets detected the contract's changed, so it then needs to compile again. It's compiled. You can see it's deployed again. We go down here, and now if we go in here, you can see that we've got a whole new contract. The front end's hot reloaded, but now if I call a different one, hopefully log a smiley face. And you can see that this got console logged here. So this is a really cool thing that you can do with Hardhat to essentially be maybe debugging contracts, maybe checking that variables have changed as you'd expect during execution. I would say the one thing which I've sometimes done when deploying is to forget to get rid of this this import, because it's obviously extra code to deploy to the chain. That's one cool thing you can do with Hardhat. So let's just jump back to the things. As I said, there's some cool things, but also potential gotchas when you're using different plugins. So one thing is that if you want to, say, redeploy your contract, in this case, Hardhat deploy detects that actually the contract's not changed at all. You might just want to and so it just reuses the same one. It might be that for whatever reason you actually do want to reset the deployment. So in this case, you can call reset and it'll redeploy the contract and give you a whole fresh new app again. So that is the basics, the bare bones, and this is really cool because you can basically be adding new functionality to your contract. So let's see when this is going to be relevant. Timestamp, and if we go public view returns mint 256, we can do this, and we can do block number as well. Okay, yeah, these two new functions, we can deploy these guys. So essentially, it's a really good place to be iterating and developing your contracts. So these will get deployed. We now have these new two fields which show up here, and yeah, we'll talk about them again in a second. So then in terms of the next stuff that you can do with Hardhat, which so we've covered pretty much the local EVM compilation and deployment. Next thing that you can do is testing, coverage and gas reporting. So let's run through those. So if I run yarn test here, essentially I run some tests. So these are some unit tests which are run, and actually I've jumped ahead here because you can kind of see this at the bottom. So essentially these are just unit tests. So if we jump into my test, you can see essentially the tests that we've just run. So what are we doing here? So essentially this is getting run on it's an instantiated local Hardhat node, and essentially checks a bunch of things which you expect to happen when you're working with the contract. So for example, you can test that your contract's deployed properly. You can test that when you call a given function, it has the effect that you'd expect. And then you can also check, for example, that an event is emitted when you call that contract. So that's again the kind of stuff which is moving to from sort of hacking, iterating, working on contracts to something that looks more like sort of software development best practices. And so again, a really rich toolkit. And one thing that Hardhat have also recently introduced is their own sort of matches, which haven't fully dug into, but again, is moving away from where they were using a sort of a prior truffle library. But so testing can give you a lot more confidence when you're making changes to your contract that they're not having sort of side effects that you wouldn't expect, and to make sure that actually when you've implemented things, that the result is what you would expect. So you can do all that within the sort of within the hard hat framework. There's some other cool stuff that you can kind of get when you're running your tests. So this table at the bottom is one of them. So this is again something that comes in the hard hat toolbox. And if we jump back to the hard hat config, you can kind of see where this is configured, which is the gas reporter. So obviously there's a large school of thought who are very focused on gas optimizations within smart contracts. And so this is one where if we look at this, this report, this essentially takes all of the tests that were run during the tests and sees what the sort of gas usage was for those tests. And so you can see within this gas currency, this gas reporter thing, this is coming bundled in with the with the toolbox. But essentially, if you call enabled get true, so I mean, if I run this again without it, you just have the sort of output of the tests. Whereas if I run with it again, you can kind of see this table, which gives you this put. And so then you can start to see, as you're making changes to your contracts, how that's then impacting different things. So for example, if we add a UN256, let counter equal counter, and then if we do, now if we do yarn test, see if I give it a second, you can now see that the increase in gas usage, because essentially I've added this new storage update, and so that's again a thing where you can start to optimize, start to keep track of the cost of different actions. The last thing I think I'd call out, and I just in the interest of time, I think I called this in, was essentially the coverage command. So this is again similarly running your tests, but also giving you a sense of the coverage of your tests. So if we jump back to my contract, you can see that my contract, I added a bunch of functions here. And if we look at my tests actually only really test out the set purpose function. So this is identifying, if we jump in here, that that actually there are some lines which haven't been covered by my tests, some the percentage of functions which haven't been covered by my tests. And again, this is a thing that just comes bundled in with the hard hat toolbox. So again, you can not only be running tests and feel confident that your changes are not having unexpected impacts, but you can also have an understanding about actually how thorough your test coverage is. So that's testing. There's a bunch of cool stuff there. If we go back to the meme, we can see that we've covered testing, coverage, and gas reporting. And so then I guess we can jump into some of this like slightly more advanced stuff you can start to do with hard hat. So we're going to talk about tasks, EVM manipulation, forking, and verification. So for example, so if we jump back to the code, if we go back to the hard hat config, again, just to orient you on the stuff that's going on in this file, we're importing a bunch of plugins that are useful. We're configuring a bunch of essentially exports or modules, and so a lot of these are actually networks that we want to interact with. You saw me like changing the network that I was interacting with, so that network configuration is a big thing here, and obviously folks in Scaffold ETH want to interact with a lot of networks here. We've got the OVM, you've got some of the again API keys or like configuration for some of the other plugins, but then at the bottom here we've got a bunch of tasks. So within hard hat you can define a lot of tasks and scripts. So tasks and scripts, there's actually a post in the documentation about when you should use one or the other, and focus on tasks today. Essentially, these essentially little snippets that can be run in the context of the hard hat environment, so you can start to interact with your chain, with your contracts. So let's run through a couple of those. I guess, yeah, so if we go hard hat world, on this one, you can see that I just ran this task, which didn't do much. It just console logged hello world. So that's not necessarily that interesting, but then you can start to see like other interesting stuff that you can do. So one thing you could do is you could deploy contracts, or you could update state variables, or you could interact with your contracts on chain through these tasks. But the thing I want to now dig into is some of the other things that you can do within Hardhat, which is kind of interesting. So that's essentially starting to manipulate the EVM. So if we take this one, so this npx Hardhat hour, if we jump back to here, essentially this is one of these sort of essentially Hardhat manipulations you can do, where you can interact with the Hardhat virtual machine to change some variables. So essentially there are a few of them that I've called out here. One is to mine a new block, so that's just to add a new block number to the chain, and this one is to change the time on the chain. So you might want to do this when you've got a variable which is like maybe you've got a game and actually you can only close the game after a certain amount of time, but you don't want to wait that amount of time, you just want to sort of move forwards in time. So if we go back again to the Ethereum app, just because then we can, I guess, have a look at the stuff that's going on in the front to get a sense of what's going on. If we go again, add an hour, and then we interact these. Okay, I know what this is. Perfect. So now we can see we mined an empty block. So when we mine that empty block, you can see that actually jump forward an entire hour. So this is a timestamp. Similarly, the block number is updated. So this is the thing where you can start to interact with the chain. And so these feel like relatively small things that you can do, but there are some others that actually let you do other stuff. So for example, like you might want to adjust your balance. So there's a help which actually lets you set the balance for a given account. So if we go back to this guy, using hello.adamfuller.eth, if we take this and if we say, okay, give me ETH, I'm going to run essentially this one, give me ETH, pass my address in here. So you can see this task was defined with this name. I added this address parameter, and then what happens is that the helpers set the balance of my account to 5 Ether. So you can see currently I've got $15, so 0.1. So we run in here. And now if we refresh, I've now got 5 Ether. You can see it's not added 5, it's actually just set my balance to 5. So if I then wanted to change this, maybe if I wanted to give myself 49 Ether, if I do this again, you can see set my balance again, you've got 49 Ether here. So again, just ways in which you can start to manipulate the state. And so again, so we've gone from like adding the time, we've gone to mining blocks, we're going to setting balance. What about doing something even more interesting? So this task lets you take some dye. So this should actually be dye. So this is a helper which lets you essentially define a user who's essentially impersonating an account. So to impersonate a sender, which then lets you make transactions on their account, which you could never normally do in a sort of normal context, and send yourself some of any specified token in this case. So just to interrogate this again, this is called take some dye. Given a token address, a sender, and a receiver, it creates this, and this could actually be much simpler. It essentially takes an ABI, which is an ERC20 ABI. It then impersonates the sender account. So Hardhat will just assume the signer is the sender account. It then essentially instantiates a contract with ethers and then transfers some of that token to you. So again, this is one where actually there's an interesting dynamic here. So we're jumping into another thing you can do, which is to not just start your local EVM from nothing, but to do it from a fork. So this is one where I'll run a special command. So I've just cancelled my local EVM and I'll run a yarn fork. So if we take this, see I've started a yarn fork, and I'll deploy things to it. Deploy. If I refresh, Actually, I've got $17 on this, which is the account I have. If I were to connect on localhost, switch network, refresh my network, you can see that actually you can see it's forked from mainnet because it's got the amount of that I've got in this account on mainnet. You can actually then deploy a contract in the same way that you otherwise would, and so then essentially, given this, I'm now essentially interacting with the chain, which looks exactly like mainnet. So again, this is a super cool thing, which Hard Hat lets you do, because you can actually start to interact with this chain. Lets you interact with this chain as if it is a real chain. So, so this is one where essentially, if we go to DAI, refresh this. Like this is the DAI contract on this is the DAI contract on mainnet, but my local fork is essentially looking at this. And so the way that this works, if we go to package.json, is that when you run fork, essentially you run a normal Hard Hat node, but you specify an RPC to use for the fork. And so then essentially whenever you call for state that's only on the main chain, that it will essentially defer to and use this RPC. And so that's, again, like a really powerful unlock if you want to maybe simulate or test what happens. I've used this in scenarios where I wanted to check what happened or verify that a bunch of transactions would have the outcome that I wanted them to. I could fork mainnet, run those transactions on my local EVM, maybe generate a bunch of signatures that do those kind of things, and not worry too much about and then I could have confidence when I actually executed them on the real chain that things would happen as expected. Anyway, so where was I? If I jump back to what that then allows me to do is then if I say, okay, let's take some DAI, I've saved this. So this is, again, on the localhost network, this is the DAI contract and sending from this DAI person to, and I'd want to specify my address here. I think that's the right one. I'll run this. You can see now, if we take my address, if we take my balance, you can see I've got 5 DAI. I've just given myself 5 DAI. Again, if I run that again, and I run that address again, I've got 10 DAI. And so again, one final really cool cool thing you can do, you can fork the network, you can send yourself DAI, you can act as other people, is a cool thing to do with Hard Hat. Final thing, I think, so again, this is just to talk to the plugin, like all of the plugins that exist on well, actually, yeah. One other thing you can do is essentially verify contracts. So one thing I could do if I want to deploy is I could actually deploy to Rinkeby. I could deploy this contract to Rinkeby. I'll do that now. This is actually deploying live to a testnet. One final thing that you can get out of the box is verifying your contracts. So now if I essentially take this contract, ID, if we actually go and look at it on Rinkeby, that one, scan Rinkeby, we are going to be literally up to the minute. If we run in here, take a look at this contract, did that work? Looks like it may not have. Maybe we're not going to make it at the last minute. Let's see. Okay, it's still indexing, but it should show up in a second. One final thing they can do, maybe it's not going to show up until this indexes, is essentially verify contracts. And so if I run this last yarn verify network Rinkeby command with this address, call this will then verify the contract. Take the contract here, perfect. See, it's submitted for verification. And any minute now, it should hopefully come back and it'll be verified. And that's it, I think. We'll wait for the verification result. So now if we refresh back in here, last thing, there's the verify contract. And that's all I got.
Amazing. Well, as usual, this wouldn't be a talk if something doesn't go slightly according to plan, but this was great. A lot of interesting tips and tricks, and I'm glad that it's recorded because I got to really dig into some of these commands to actually do this on my own too. So appreciate this, Adam. Thank you so much. I hope everybody in the audience enjoyed this primer as well. And unfortunately, we are a little bit over time, so we don't have any time for questions. But if there are any that come up, I will send them to you directly, and then we'll answer them back to you, the person who asked those questions on the chat. So thank you so much.
Thanks very much.
All right. With that, we are ready for our next talk. And I'm super excited to welcome Taz, smart contract programmer, to talk about Solidity best practices and 10 tips to become better at developing Solidity. So without further ado, let's welcome Taz. Hi.
Hello. What I do? Can you guys see
We can
me?
see you and we can hear you. You're all good to
All
go.
right. Let me try sharing my screen. And can you see my code editor?
Everything is good.
All right, thanks. All right, so for today, I'll be talking about 10 Solidity best practices. They're not in any particular order. They're not in any particular importance. They're just some maybe things that I learned while learning Solidity. And I'll share them with you guys today. So the first one is to lock compiler version. So the bad practice is to have a compiler version set like this with a caret. And this will mean that your Solidity version can be anything from 0.8 and less than 0.9. And the good way to do it is to lock the compiler version, and it means to set it to a specific version. For example, here we're setting it to 0.8.13. And the reason why we want to lock compiler version is I'd say that it's mostly for when you deploy a contract and then try to verify it. By the time you deploy a contract, you might have forgotten which version you deployed it with. So it's really helpful that you lock your version. You go back to your code and say, oh, so I know that I deployed it at 0.8.13. So you'll remember it and you'll have an easy time verifying smart contracts. The other reason is sometimes Solidity will announce bugs. And if you know your version, then you would know if your contract has a bug or not. So that is one recommendation, to lock your compiler version. Okay. So the next one is multiply before divide. I see a lot of developers, new developers, asking the question, if I have a number like X, how do I get like 90% of X? So one way that you might think that you would do it is to say X times 90%. So it'll be 90 divided by 100. And here we're dividing 90 over 100 and then multiplying X. And the reason why this is bad is because in Solidity numbers, there's no decimals, so numbers round down. So when you divide 90 by 100, this will evaluate to 0, and 0 times any number will be equal to 0. So the better way to do this will be to first multiply your number X by 90, and then divide by 100. This way you will, there might be some rounding errors, but this way you'll get close to 90% of X, assuming that X is maybe greater than 100. So that's multiplying before divide. And in the real world, you might see code something like this, something like calculate ratio of shares. The bad way to do it will be to maybe okay, so first of all, here, let's say that we have a contract and it keeps track of the total shares in the contract and the number of shares per user. And the bad way to calculate the ratio of shares is to simply divide the shares of the user by the total shares. Total shares will be most likely be greater than the shares of the user. So this will most likely return a 0. So this is the bad way to write your code. A good way to do it is to say that 100% will be equal to 10 to the 18. And then you will first multiply the shares of the user by the multiplier. Here, the multiplier we define as 10 to the 18. So here we're multiplying the shares by 10 to the 18 and then dividing it by the total shares. You'll see code something similar to this inside the Curve AMM contract. So they will multiply by some large number and then divide by another number so that their numbers wouldn't round down to 0. So that is multiply before dividing. So the next best practice that I learned is to don't name local state variables the same. And what I mean by this is, let's say that we have some smart contract and it has some state variable. We'll say the state variable name is total supply. And we have some function, and inside this function, we might declare another local variable, also the same name as the state variable. And let's say that we set it to some number 1 to 3, and there will be a lot of code in here. And at the end of the code, maybe our intention was to update the state variable total supply to 456. But when we execute this code, total supply inside this function refers to this local variable. So what we're doing here is setting the local variable to 456 instead of our intention being to set it to the state variable total supply. So this is bad practice to have the same name for the local variable and the state variable. And the Solidity compiler will give you warnings, so be sure to read the warnings. And the better way to do this is to just simply have a different name from the state variables and the local variables. Now, I want to mention that in Viper, all state variables, so this will be in Viper, all state variables start with self dot my state variable. So you wouldn't have this trouble of keeping track of which variable is a state variable and which one is a local variable. So this is one useful feature of Viper. Oh, okay. So as a bonus, when you're dealing with peer functions, again, peer means that the function does not read any state variable or any data from the blockchain. So one benefit of using peer function is that inside the peer function, you know that it's not going to touch any state variable. So there's no name collision between local variables and state variables. So that was tip number 3. Let's move on to tip number 4. Keep contracts simple. This applies to a lot of programming, and especially also applies to smart contract programming. And the reason why you want to keep your code simple is that complex codes are hard to analyze. So it probably means that the code might be less secure, and there might be bugs that are hard to find. So you would want to keep your code simple. And what are some examples of complex code? Well, it might be like inside a function, it's calling many other functions and contracts. So it's hard to keep track of what's going on inside this function. So this will be a complex code. Another example of a complex code might be that the contract is trying to do many things. For example, it might be this contract might represent AMM, so you'll be able to swap tokens. And it might also represent like a DeFi lending and borrowing. So inside this AMM contract, you might have other functionalities to lend and borrow and liquidate tokens. So trying to do many things inside one contract is not good practice. This is my opinion, but it might, when I see a lot of BU functions inside the smart contract, I think it's unnecessary complexity inside the code. For BU functions, you can usually move it to another contract. So we'll see in a second what I mean by this. So good code will be simple contracts. It will be simple code. And inside the contract, what I try to aim for is to do as little as possible. And if I need to ask the question, do I need this function or do I need this BU function inside this contract? The answer is most likely no. And the way I would know it is if I'm asking that question, then the answer is probably no. If I don't have to answer that, if I don't have to ask that question, then it's probably obvious that I do need that function. So that's how I decide which function goes inside the contract or not. And one thing that I always like to say to myself is YAGNI, which stands for you aren't gonna need it. You're not gonna need that extra BU function. You're probably not gonna need another function inside your contract. Keep it as simple as possible. So a good practice that I noticed in some contracts, in some DeFi projects like Uniswap B3, where they split some of their core logic from BU functions. So they would split the logic of a price oracle into another contract from the AMM contract. For example, you have some kind of core contract, and then as another contract, you have a BU contract. The core contract, if there's a bug, then you can't really fix it. But if there's some kind of bug inside the BU contract, then you can throw this one away and rewrite another one and then deploy it. So I think this is a good pattern to split the core contracts and the BU contracts. That was keeping contracts simple. And the next tip is to prioritize security over gas. So for example, what I mean by this is that sometimes you would see code that are optimized for gas, but it becomes really difficult to read the contract. So there might be bug, but you can't really see the bug because the code is complex. For this example, here I have some kind of loop, and it's trying to optimize for gas. So if I take a look at this loop, it looks like a regular for loop, but instead of having an increment of the counter inside here, I do like an uncheck and then increment the counter inside the loop. This code is a little bit hard to read, but it does save gas. On the other hand, the good practice would be to prioritize for code readability and security. So what you might do is write a regular for loop that everyone is used to seeing. So that's security over gas. The next tip is avoid unbounded loops. And what I mean by unbounded loops here is that there is no upper limit to the number of loops. And why is this bad? This is bad because there's a limit to the amount of gas that can be inside a block, and unbounded loops means that it's going to consume more gas than the block gas limit. So at some point your transaction will fail. So let's take a look at some examples of an unbounded loop. Here I have a state variable called accounts, and I have a mapping called balances. So it will map from account to the balance of the account. And to make this array of addresses accounts unbounded, we have a function called join, and it pushes an address into the account's state variable. So example of a unbounded loop will be to loop over all of the accounts. And here we're just updating the accounts by adding 1. Why is this bad? Well, imagine if 10 accounts, if there are 10 addresses in the account, then it might use a certain amount of gas. If there are 100, then it's going to use more gas. And if there are 1,000 accounts, then it's going to use more gas than that. And at some point, you'll hit the block gas limit, and this function will always fail. A better way to handle unbounded loops is to have some kind of upper bound to the number of loops. For example, here inside the input, we're saying start the loop from start and end it at end, and we do a loop. So this function would never be, it will never fail because we can always bound it from start to end. Another example of a unbounded loop, this is a subtle one, but let's say that we have some kind of function, and then inside the function, it calls another function, it calls test2, and inside the function test2, it takes in an array of addresses. And notice that here we're passing in a state variable, array of addresses, but here we're passing it as memory. So what this means is that all of the addresses inside the state variable accounts will be copied over to memory. So basically, we're running a for loop here. So this is an example of an unbounded loop. And to show you this, I wrote the test. Let me try opening it. Unbounded loops.test file. And what I did was the first test, I call join 3 times and then run the test. Next, I call join 10 times and then run the test. So what you'll see is that going back here, what you'll see is that when there are 3 addresses in the accounts, it will use a certain amount of gas. But when we have 10 addresses in the account, it will use more gas. So I'll copy this. And open my terminal and then paste it. And then you can see here that test gas 2, this is a test with where we have 10 addresses in the account. It used up more gas. This was a subtle example of an unbounded loop. Try to avoid it. Okay, so the next one is to don't trust the user inputs. What I mean by this is that if you have a function where any user can call, and let's say that it takes in some kind of address of a contract, and then inside it, here we can see that it's calling into a token and calling the function transfer from. But since we're passing in user input, the user can put in any contract address as long as they have a function called transfer from. So which means that they can execute any arbitrary code. And for example, what we can do here is have a user, the user might have deployed a malicious contract, and then they will call this function. And inside that function transfer from, that malicious user would put their malicious code inside here. For example, for this example, we just log the message called hacked. And what will happen is that when the user calls the function deposit, it will execute, and then they will pass in the address of this malicious contract. It will call transfer from and execute this code. So this is what I mean by don't trust user input. And I cannot remember from the top of my head, but I do remember that there were several DeFi hacks where the user were able to put in their contract address to do some kind of hack. The next tip is checks, effects, and then interaction. So what I mean by this, checks means that first check the inputs. Effects means that next update the state variables or do some kind of change inside your smart contract. And interaction means call other accounts or contracts. So the best practice here is to first check user inputs, next to update your state variables, and lastly to call other external contracts. So first of all, let's take a look at a bad example. A bad example would be to, you can see over here, called withdrawal bad. Notice that instead of checking, it does no check. And then next, it calls into another contract, but transfers the ETH to message.sender. And then lastly, it updates the balance of message.sender. This is the effect part. What you want to do instead is to have something like this: check, effect, and interaction. The check will be to check the user input. For example, amount is greater than 0. Next will be the effect. So updating something inside this contract. Here we're updating the balance of message.sender. And lastly, to call external contract. For example, here we're sending the ETH to message.sender. This way, this code is not vulnerable to reentrancy attack. However, this withdrawal bad is vulnerable to reentrancy attack. Okay, the next tip is to use reentrancy guards. So in the previous tip, we said to use check, effects, and then interaction, but this does not guarantee that your code is safe from reentrancy attack. So whenever you're in doubt, then, well, at least for me, whenever I'm in doubt, I always put like a reentrancy log, and so that I feel safer that my contract is probably more secure. So what do I mean by a reentrancy guard? A reentrancy guard is a simple modifier that first checks that the state variable logged is set to false, and then it sets it to true, and then executes the code. And then after the code executes, it sets it back to false. So that if there was a reentrancy, it will execute this part of the code, come back in, and this, since the lock is true, this part will fail. And this is how it protects from reentrancy. Let's take a look at an example. So here I have a bank. You can deposit into it, and you can withdraw. Notice that this function does not have a reentrancy guard, whereas this one does. To show you an example, I wrote a hack to do a reentrancy. And to do a reentrancy, I'll run this command. So I'll be calling this withdrawal function once, and if the test passes, then it means that the reentrancy was successful. So I'll execute this test, and the test was successful. So that means that the reentrancy was successful. Next, I'll put a reentrancy lock on this function called withdraw, and then we'll execute the test again. This time the test will fail because the reentrancy lock is protecting that function. And you can see here that the test failed. So that's reentrancy lock. If you're uncertain if your contract is vulnerable or not vulnerable to reentrancy attack, then just put a reentrancy lock and feel safer with your contract. Okay, the last tip is pull over push. So what do I mean by push and pull? Push means that the contract sends ETH or token to some address. On the other hand, pull means you allow the caller to withdraw ETH or token. And why do we recommend pull over push? Well, first of all, if you do a push, it might be vulnerable to reentrancy. And there's also a chance that you accidentally send it to the wrong address. So let's take a look at some code. So a bad way of example of a push will be to directly sending ETH to some address. But notice that if we were to put in some wrong address here, then this would send ETH to the wrong address. Another example might be to like send ETH many, even though that, let's say that most of the addresses inside this receiver are regular users, but one of them is a malicious user, and this person decides to reject all ETH sent to this address. Then this function will fail, even though most of the users are regular users. So that's another reason why pushing ETH to another address is not recommended. So here's an example of sending token. A better approach is to let the user pull the token. And what do I mean by this? Well, it's going to take two steps. First, the contract approves the user to withdraw from the contract. So here, for example, I have a function called give ETH, and it will increment the ETH balance for the address 2. And if for some reason we put in the wrong address, then we can easily fix this. And once this ETH balance is incremented, the user can call withdraw ETH, and this will only decrement the amount of ETH that was allocated to them. So this will be the user pulling some ETH into their address. And the same example for ERC20 tokens, we can increment the balance of the token for address 2 and let the user pull token. And that completes the 10 best practices that I picked up learning Solidity.
Amazing. That was great, and also very concise and to the point. Now, people were super excited. There's two kind of common questions that came up. One is in your pure functions example. We want to clarify if that's a typo where it says total supply. I think there was it just says TOTA supply. So wanted to see if that's where the collision wasn't coming from, or was actually like a typo. So we'll get that cleared for the person who asked that question. And the second request is if you are able to share these 10 examples of the code, whether it's through a slide deck or just a GitHub repo, they'd much appreciate it because they want to themselves as well.
I'll send you the links, or do you want me to put it on the chat?
To me directly or in the chat too, and we can also communicate that to all the hackers on Discord too.
Okay, I'll do that.
Well, thank you.
Oh, sorry.
Yeah. Sorry, in case you want to address the first one, you're more than welcome to, but yes.
Maybe create a GitHub issue, because I think we're almost done. Yeah.
Yes. Well, thank you so much. And this was great. And thank you for doing this thing and doing this thing super late in kind of your time zone. Really appreciate it.
Yeah, it's all right. No problem. Yeah, thanks.
Absolutely. All right. Next up, we are going to do a similar thing, but for Viper. So without further ado, I'd like to welcome Garrett, who's going to talk about how do we actually use Viper and build more interesting things and use DeFi as example base for getting the best out of the Viper Lang. So Garrett, feel free to turn on your camera and get started. Excited to have you.
Hi, Kartik. Thanks very much for having me. Very excited to be here and addressing everyone worldwide. I think you nailed it. We're here to talk about a lot of topics around specifically some of the tooling that I think makes Viper really, really great. And in particular, the use case that I'm going to be focusing on is how you can apply Viper to DeFi. But open to kind of talking about anything. What have been some of the kind of highlights you've seen so far?
You are the third talk, and we're just sort of ramping up as we kind of go into more and more in depth of different dev tools and SDKs out there. So I feel like people are slowly building towards learning about the internals of libraries that they use, like Ethers and WAGMI, and we're going to kind of start from languages to SDKs. So that's the plan for today.
Excellent, excellent. I'm very excited to be giving this talk here. Let me get my screen share going real quick, because this is a bit of a modified version of a less technical talk that I was giving in ETH LATAM. Back there, I was focusing on introducing Viper to a broader audience, but it was not a technical talk specifically. So in this case, I'm going to be talking more specifically about some of the tooling, and specifically Brownie and ApeWorks, as well as the newer Titanoboa. So all of these are really great tools. They can be for the first two used with Solidity as well, but Titanoboa is native to Viper. So first I'm going to give a bit of background because I expect most people are very familiar with Solidity. And I wanted to talk a bit about some of the things that, some of the origin story behind Viper and how it is that it came to be what it is and where it might be advantageous in some ways, or it might have some drawbacks. So many people don't know this, but Viper was actually started by Vitalik himself. This was his concept way back. It was a language called Serpent, and it has quickly outgrown Vitalik's initial vision for this. So Viper is no longer directly developed by Vitalik, but it has sort of like evolved, and the community took it over and really decided to take this into kind of the next level. And while you might think that this means that Vitalik is in some way casting aspersion on Solidity or something, like I just want to start this by saying that I teach Solidity for a night class. So I like Solidity, I like Viper. I think both are great languages. And this is not intended to cast aspersions on any particular language, but just want to give some pros and cons of both. And also to point out that all of us are really united in our shared goal of having multiple different languages. Like the EVM, the Ethereum Foundation is actually working on additional languages beyond just Viper and Solidity, because we want, at the end of the day, all of us unite in wanting more great smart contracts to get deployed. So if some people want to deploy using Solidity, some with Viper, and we have 15 other languages that make more developers comfortable and feel good writing code, like this is what unites all of us. So for example, one of the other emerging options is FE. There's a lot of, hopefully we end up with a lot of different ways, because at the end of the day, these are just human level abstractions. And what we're really trying to avoid is writing this extremely raw level bytecode. Because anyone who's had to manipulate bytecode knows that it's not as bad as it first looks, but it's much better when you have these higher level interpreters that allow you to do like much more significant, like significantly readable and understandable options. And this gets to why you might pick Viper over some of the other languages, because more than a lot of other languages, I really see how Viper as a language has been shaped by its core values. So from the start, when Viper was launched, it decided to rebuild this sort of smart concept of a smart contract programming language around three core values. The first is security. And anyone who's been in cryptocurrency knows that this is absolutely critical because there's such an amazing number of hacks, it's mind-boggling. And Viper wanted to address this with its actual syntax and say that at the development level, it should be possible and actually just fully natural to be able to write secure smart contracts. That is, if you're a new person writing the code, it should have security embedded by default so that you don't have to have an advanced level of understanding to be able to write smart contracts that aren't going to get hacked. The second value is simplicity. It always strives to make the code easier to understand for the reader, even if this comes at the expense of the writer. And going a bit further, it prioritizes simplicity for readers who even don't know how to code. And this is one of the reasons that Viper is architected off Python, because Python as code is fairly legible, even to people who don't understand what's going on with its human readable syntax. And this ties into the final point of auditability, because we know that auditors do their best, but they can't always catch everything. It can be very, very difficult for auditors to catch all the bugs in code. So Viper wants to make it difficult to write misleading code. And this has fueled a number of different design decisions. So if you're familiar with Solidity, when you're getting started with Viper, you might be confused by some of the things you're very used to in Solidity not having an equivalent in Viper. It was chosen to simply not include it at the core like architecture level because it sacrifices one of these principles. For example, Solidity, it's common to include like an only owner modifier. Viper doesn't have modifiers because they thought that it would be too much work for auditors to have to jump back and forth between modifiers and the function calls to understand what's going on. Similarly, there's no function overloading because that could be a security risk. You could have an overloaded function where you're expecting you're calling one version that's fine and you actually call a different version that does something different. Viper is not Turing complete because the EVM is itself not Turing complete. Solidity is technically Turing complete, but it's running on a non-Turing complete EVM blockchain. So Viper within the language caps all of its loops. Solidity doesn't. You could theoretically write an infinite loop in Solidity. It won't execute because the EVM will run out of memory before it can execute it. So Viper puts this restriction into the coding. And this can be an issue for some people because you have to have all your arrays capped. It used to be the case you couldn't have dynamic arrays. Now you can, but they still have to have a maximum size. And because of this, Viper is not having to use this dynamic array pointer when it's deploying code, which means it can deploy very, very efficiently. But it also has this trade-off in that you aren't able to have like an unlimited array. So for example, if you have to define the max up front, that can be off-putting to some people. Another one we'll talk about is no raw bytecode and no inheritance, although this is going to change. So no raw bytecode means that there's not a way of just injecting a couple of lines of bytecode here or there because it sacrifices this capability of being easy to audit. With Solidity, you can inject raw bytecode. And as a result, Solidity actually has the advantage on this if you need to, for example, like we'll talk a couple examples where being able to inject raw bytecode gives Solidity this incredible efficiency, but it comes at this expense of readability. Whereas Viper forces the readability and relies on the compiler to get the efficiency out of it. And no inheritance for now is another drawback, which we're going to talk about in just a second. But this brings us to where these different principles and this difference in architecture has really caused sort of, in my mind, a difference in the ideal use cases. So Viper has a lot of advantages in terms of it's really efficient in terms of compilation costs. And generally speaking, it's slightly more gas efficient out of the box. But some of these things give it a bit of drawback. So I'll be the first to say that Viper has never really been good at NFTs. And as a result, I think that Viper has kind of ceded this ground because Solidity's advantages make it a sort of natural fit for NFTs. So we mentioned that some of these advantages of Viper are things like it's very good at gas optimization, but NFT people don't particularly care that much about gas optimization. Every NFT that gets minted has this theoretical optimum price, and it doesn't really matter to the user whether they're paying that to the contract or they're paying that in the form of gas wars. And as a result, we've all seen the experience of wanting to make a transaction and having to wait because the gas prices have just spiked because there's some new NFT drop. It costs 0.01 ETH to mint, and people are spending $500,000 to mint it. In fact, this year, the other side meta had set some records in terms of the amount of gas that people were paying to mint this. So even though Viper may have an advantage on gas, it doesn't really matter in this space. Similarly, like Viper might be more auditable, but generally speaking, like NFT contracts are fairly easy to kind of cut and paste. So they really benefit from the Solidity capability of importing modules. You can, for example, use Open Zeppelin templates. If you're at all not concerned about gas, they cost a little bit more, but they're very readable. So it's easy to kind of be able to plug and play. And no one is really particularly caring when they're auditing this because they're not expecting to get money out. They're throwing money at it, hoping to get an NFT out. And they don't particularly expect that their deposit, they don't worry if it gets hacked. They just care about reselling their NFT at a later time. So as long as the core NFT contract works, like you can just use the Open Zeppelin documents and you'll be fine. And by and large, like a lot of NFT people are not going to be reading through the code. So the corollary to this is that Viper kind of punches above its weight in DeFi, in my opinion, because people do care about things like security, auditability, and these core values that have been built into Viper. So it's sort of slight because by far, like 99% of contracts are still Solidity. But I say that Viper punches a bit above its weight in terms of the total volume that's been entrusted in dollars terms to Viper contracts. Even though it's about like 99% of all contracts are Solidity, Viper has about 10 to 20% of the TVL, largely through like Curve Finance, Yearn, Lido Finance. Similarly, the gas optimization within Solidity versus Viper benefits Viper in that a few GWei worth of gas savings can be a huge difference when you're talking about smart contracts and DeFi. It can be the difference between using one exchange versus another. So for example, it's very common to see one exchange will be cheaper in terms of its like underlying gas usage. It's cheaper in terms of like gas usage, but it might be more expensive for slippage. And if whether it's a big or a small transaction, you'll default to one or the other. And finally, a lot of the kind of underlying properties of how Viper has been architected at the compiler level includes a lot of higher level math functions. And I think that for a lot of the DeFi contracts we've seen, we're really scratching the surface of kind of more complex functionality built into it. And a lot of the math is there and screamingly efficient within Viper contracts. Moreover, there's no such thing as a stack too deep error within Viper. So if you want to write this contract with extreme levels of complexity, it's just a bit easier to do it using Viper. So my contention is that they're both good choices for, in some cases, they might be better suited in a use case. Both are actually, Solidity and Viper are great for both of these. So of course, like there's some really fantastic protocols built in both Solidity and Viper. But recently there's been this phenomenon emerging, which has been popularly called Hot Viper Summer, which is where this past summer, more people have been looking at Viper and giving it kind of a second look and trying it out. Part of this is because Vitalik, former founder of Viper, went ahead and started to promote it. But the real difference was when Viper 3.2 to 3.3 got released. And before this, there was actually structural differences. Like you couldn't have some ABI types in Viper that were supported in Solidity. And this is one of the reasons that Viper really was bad at NFTs, which was that you couldn't have a bytes 4 type in Viper before version 3.3, and the OpenSea API required this for checking interfaces. So it was not possible to get a Viper NFT on OpenSea, to my knowledge. Maybe someone figured out a hack, but I believe I'm the first person to have done it. So I feel pretty excited about that. So people started taking a second look at Viper and found that when they first tried it a year ago, it wasn't quite there, but now it not only has all these efficiencies, but the compiler and the interpreter is really great to work with. So this became, at this point, more of like a preferential choice. Like there wasn't any structural reason why you might need one or the other. And people started saying, well, let's take a look and see. And now there are different arguments against Viper that started to emerge. Like some people said the ecosystem wasn't as big as Solidity, which is very much true. The Solidity ecosystem is huge. The Viper ecosystem is small, but very, very friendly. And I would definitely invite people to join the Discord to find out more about it. And this brings us to tooling, which is the second thing that was listed as a drawback. Because there is a lot of advanced tooling that's been created for Solidity. But in the past few months, Viper has really caught up on the tooling level as well, particularly when we get to Titanoboa to talk about it. So as we dive more into this question of Viper tooling, I wanted to bring up one of the first things that people always bring up, which is Foundry support. Because Viper, here's one particular person who tried using Viper during Hot Viper Summer and found it worked pretty good, but was still looking for a bit more deep Foundry integration. And when you're dealing with complex contracts, felt familiar with Foundry. So for people who do want to use Foundry, we're not going to touch too much on it, but I do want to point you to this repo that OX Kitsune has been making called Foundry Viper. And it's very actively maintained, and it's a Foundry template that allows you to compile and test Viper contracts. So if you want to work within Foundry, you can do this. Similarly, if you like Hardhat, there's a Hardhat plugin. But a lot of people within the Viper community opt for Brownie. And I wanted to walk through a couple of use cases of some like ERC20 applications using Brownie. So if you're not familiar with Brownie, it's a Python-based development and testing framework. And it supports Solidity as well. And it works very well with Solidity. I've used Brownie to build entirely Solidity-only repositories and applications. But because Brownie is itself Python-based, it sort of is a natural fit for Viper, which is itself also Viper-based. And it uses PyTest for its testing suite. And if you've had the privilege of using PyTest, you'll find it's a very robust framework. It can do many things that you need to do for building out tests for your contracts, including property-based and stateful-based testing using Hypothesis. And then there's a bunch of great debugging tools built into it. So it's an incredibly robust framework for testing a lot of these DeFi applications that are built using Viper. So Curve has built out very extensive repositories in which they have robust testing for incredibly weird edge cases using Brownie. And because it's been very efficient at utilizing this PyTest framework, it's been, to date, there's been not a single backend hack of Curve, although I'm always afraid to say that because I might look over and see that while I'm speaking, it got hacked. But I'm going to walk through just a couple of quick use cases for how you can actually use Brownie to quickly get up and running using a simple ERC20 token. So within Brownie, there is a bunch of pre-built Brownie mixes. And these are some templates that people have created and published to GitHub that allow you to just quickly import a project into Brownie. And I'm going to use the example of a Viper token, which is going to just clone the repository and create a Viper token just like that for us to work with. And we'll pop into here and I'll take a look and walk through what this default token looks like. And it's still on version 2.0, but this should still work fine if you bump it up to version 3 or higher. Which is where Brownie is now, or sorry, Viper is now. And walking through the syntax here, you can see that the entirety of this is actually legitimate Python. So this would be Pythonic itself in terms of all the syntax. With these first 20 through 40 some lines, there is all this up through line 31 is all the contract level state variables. So we're able to include everything we need from the ERC20 token in terms of a single hash map of balances and allowances. And that gives us everything we need to be ERC20 compliant. Line 11 here is the check for that. Line 14 through 22, we're defining the events that we're using to log and emit. Our constructor function uses the underscore init function. And everything else, most of it is actually the doc strings, because Viper, one of the nice things is the compiler is also very strict about making sure that the doc strings are properly formatted. And as a result, most of the code here is actually just the level of documentation provided. But we see it, all the balance of, allowance, approve, all the classic ERC20 functions are included here. Within Viper, you have to have your internal functions preceding when they're called. So in this case, the transfer function is utilizing this, which simply does an assert to check if the balances are viable, and then it makes a transfer. Transfer from works about the same. First, it checks the allowances, then it updates the allowances with the using subtract equal value, and then we return true. So included within this repository is also a variety of tests. So you can see within the PyTest framework, you always have a conf test, which is going to be the fixtures. In this case, there's only the one to create a token and deploy it. And then loading through the tests, we'll take a look at, for example, test approvals. All the tests are written out here. I'm going to run the tests on this side so we can see what it looks like. And we have 38 tests in total. The tests all, they've compiled, you can see them running. They're going to be fine here because we don't have any particular issues with this. I'll walk through what it looks like and some of the debugging tools inherent in Brownie so we can see what it looks like when the tests fail. But as expected, the sort of simple Viper contract we have is everything that we need. And if you want to also, you could fire up a console either by running Brownie console, or you can run some scripts and pop into the console that way. So coming with this is a script that just deploys a token to the console. So if I run this script and then I run this in interactive mode, it's going to drop me on the console when I'm done with it. So I'll run the token script. It's going to deploy a token for me. This is the most recent token deployed here. And now I can use this console to do any amount of interaction with this that I'd like. So it comes built in with, in addition to all the functions, it has a few different kind of properties built into Brownie to access these contracts. So for example, I could transfer, let's send account 1 half my balance. And this is going to default to account 0 unless I pass a specific object. But now I have full transaction, which I could use to query a bit more information. So that's been added to the history object here. So I could look at history -1 and check the gas used on it, for example. Or I could get more information about the transaction, which is going to give me the hash, the from, 2 addresses, and all the events contained within it. And there's also the capability of running a trace on it, which is quite nice. So this was a very simple transfer. You can see it called transfer, and then it called the internal transfer function, and it gives some of the gas usage. So the gas, the transfer function just used 315 gas, and then the internal function used the bulk of it, plus 21,644 for gas. So where this is useful is when, of course, not when the tests go well, but when the tests fail. So let's change one of these tests to fail and see what happens. So let me look at tests. Let's do a test transfer. Oops. And let's go down to, let me do transfer from, actually. And I'm going to change. Actually, instead of the test, let me change the contract itself. And we're going to change this. Say we made a bug in this, and instead of transferring money, we transferred 1,000 times the money. We're going to run our tests again, but this time we're going to run them in what's called interactive mode. And when you run in interactive mode, it's going to give you, if the test fails, it's going to drop you onto the console that we just saw, but it's going to drop you in the console at the place where the test failed. So in this case, this was a revert because of an insufficient balance. And when you're here, you have access to anything within this test. So if we look at the tests specifically, we were on test transfer, the first test here, and it failed. So we have for example, token and accounts and amount are all available to us. We can see what the amount was. We can see what the token is. We can try the transfer ourselves if we want, or you can look at the most recent transaction that was attempted, kept in that history log, the final element, and you could run a full traceback, which gives you a Pythonic style error message telling you exactly where in the contract it was. So you can say, okay, this was at line 105 on token transfer. Sure enough, the line that I was futzing with right here, it's saying that this is throwing an insufficient balance. So of course, this is a pretty easy test to figure out what went wrong here. But when you're dealing with much more complicated testing, the capability of being able to bounce into the specific line that you failed on, sort of like a breakpoint, and work with it is fantastic. So this is like some background on Brownie, which is a fantastic tool. But for people who are new to this, I would actually recommend, well, one last thing to point out is there are some more advanced features built into Brownie, such as the capability of seeing a full coverage audit. So this is actually just going through the code, showing the opcodes on the side, but also showing the graphical view of how well my code has been tested, so I can guarantee I get to 100% test coverage. There's also like a gas profiler built in, so you can pass the gas flag and see what the gas usage of all these functions were. So Brownie's great, and it's an incredibly robust tool. But that being said, if you're new, I would actually recommend that you, instead of starting with Brownie, you go with the next evolution up, which is Ape Framework. And here we see the gas profile come out here. And this is just giving the average low and high amounts of gas used for all the function calls, which is useful for seeing which functions are using gas. Anyway, Ape Frameworks is, you can think of it as the successor to Brownie. So Brownie is great, but it's not really building out in the way that Ape Frameworks is. ApeWorks is a clone of Brownie. So you can think of it as Foundry is to dApp tools, as ApeWorks is to Brownie. So ApeWorks is rewriting Brownie. All the functionality they just showed off also exists in ApeWorks, but they have a much bigger plans for going forward. And they also have a bunch of great educational tutorials that you can walk through. So their ApeWorks Academy has the capability of cloning ERC20 token and deploying it in ERC721 NFT. They have more that's coming and a great community. So highly recommend you check out ApeWorks. I'm not going to go into too much depth on ApeWorks because it's largely very similar to what we just showed off with Brownie, but I will show off the kind of equivalent of how you would create an ERC20 token and the very friendly way in which they do it. So it uses this templating system within Ape Frameworks. And this is going to create an ERC20 token. It's going to ask for a few different initializations. So I could say ETH token, and call it ETH token, 18 decimals. We'll add a pre-mint amount. It's ownable. We'll have a minter role. It's mintable, burnable, permittable. And just like that, it's created this ETH token repository for me right here with everything already filled out for me. So even friendlier than Brownie, as you can see, in terms of the user interface and actually building this out. And it's much more recent Viper version, which is nice, 3.3. I'm running a bit shorter on time, so I wanted to go through the kind of more newest tool, which is Titanoboa. Titanoboa is this natural execution layer for Viper language code. And Titanoboa is, in my opinion, sort of mind-blowing. It allows you to execute raw Viper code directly within Python. So this is incredibly useful for things like being able to create Jupyter notebooks, and within it actually like interact directly with live smart contracts and pull the stats natively into all the advanced mathematical libraries that you can utilize using Python, such as, you could use sklearn on this, you could use pandas data frames. So some of the things that you can do using Titanoboa, you can do storage enumeration. And what we can see by this, the example, which I'd walk through if we had more time, is you're actually able to read through all the storage variables of a contract, including mappings. So if you want to see, like, mappings are not generally readable as key value pairs. So if you have a mapping, you can't easily enumerate it within the smart contract, but you can, using Titanoboa, just rip through all the storage enumerations. So you can trace and enumerate the storage with this syntax here. In this case, we're loading a contract, minting 3 times, and then checking the 3 balances and looping through them. Very recently, they added the capability of doing mainnet forking. So just beware as you're doing this. This is caching the RPC results using level DB. So subsequent state fetches the state are very, very fast. And this is very useful for running simulations against the actual mainnet state. So this is where you can take live code and run it through your Jupyter notebook and come up with very nice, beautiful graphs. So here we see a test function being ran through IPython, deploying it, and this on this connected to a local mainnet fork is able to pull live data from the blockchain. Gas profiling is another really useful one. I showed how you could get the function level gas usage using Brownie or Ape, but if you want to get line by line gas usage, you can enable gas profiling and walk through on every single line the gas usage of every single statement. So this has been, I feel really bad about this because I basically had to write something very similar, mostly by like trial and error when I was trying to build out a recent contract. And then after I did that and launched and shipped my contract, this got released, and this would have saved me so many hours of being able to kind of figure out the specific lines where there's issues. Also can do opcode patching. So this is the capability of patching arbitrary opcode implementations directly into the virtual machine in case you need to run some finely grained tests. So this here is an example of using SStore, which is tracing all the touched storage slots by address. Anyone who is familiar with Foundry will be familiar with user-defined cheats. And this is now available using Titanoboa as user-definable precompiles. In this case, you can see it registering it and executing this raw call as it is touching this right here. So this is a simple example of printing the sender to standard out, but anything that you can do in Python, you can now do here. So you could tracing, you could do HTTP requests. This kind of opens up the full power of Python to this here. You can execute arbitrary code. So you don't even need to spin up a contract. Like in the previous examples, we were writing a contract, deploying it and testing it. But there's also a BOA eval function where you can evaluate raw lines of Viper code and get the result directly to standard out. And for debugging revert reasons, so in this case, this is there's two types of revert reasons. You can get the revert reasons here. This is a general mechanism to filter on the physical revert strings. So this could be Brownie, NatSpec, Oxygen style revert strings, or even compiler generated checks. And here's an example of the compiler revert reasons. So if the compiler is throwing an error, you can actually load this in and see what the error that's being called is. So Titana BOA is becoming a very, very robust and powerful tool for all of your smart contract needs. The team behind Viper has big ambitions. Big Tech Sucks on Twitter is one of the founding team members of Viper. He has very ambitious plans to get Viper to the best user experience and developer experience for smart contract languages, safest and most performant language for EVM programming, and highest use smart contract language for new projects within the next 6 months to 1 year. So if you're interested, please do join us. Feel free to reach out to me. I write a daily blog on DeFi stuff, except weekends, on curve.substack.com. You used to be able to find me on Twitter, but because I've been supporting the Free Alex movement, I'm no longer findable on Twitter, so find me on Lens instead. Or if you're old school, you can find me on LinkedIn. And finally, if you'd like to join the Viper community, the best place is the Discord, where the team hangs out all the time and returns in almost real time feature requests. So it's a fantastic place to be, and they're incredibly proactive and get some help. So if you follow this QR code, we will see you in the Discord. Thank you very much.
Garrett, that was absolutely amazing. Thank you so much for going into so many deep dives and telling us about all these tools. Even I didn't know about the last one, so that was great and learning for me too. We had two questions. One of them was actually answered by another member, but I'll just ask it because we're also recording it, which is when you were doing the testing, was there a way to verify the contract once deployed with the same way in Brownie, or is that only for testing in that part? Looks like the answer is you can verify it, but if you want to maybe add any other colors to that, please do.
No, I think they nailed it right on the head. It's 100% you can do that using Brownie. It's also like Brownie works. I should have mentioned that it works just as well for if you want to work on a developer local chain, if you want to work on a mainnet fork, or if you want to go directly on mainnet. So I actually do most of my smart contract interaction directly on Brownie on a mainnet, just because it's like easier for me to query and see what's going on under the hood there.
Awesome. And the other one was people wanted to know what is your terminal setup and what a terminal app do you use?
So as you see, I'm fairly old school. Like I do everything. I don't ever use like any IDE or anything. I just do everything directly within Vim. And then I am basically using Brownie and Python for everything. So yeah, I'm boring.
Okay. Well, thank you so much. And I really appreciate taking the time today.
My pleasure. Thank you.
It was Garrett talking about Viper and how you can get started with building more secure DeFi apps and also simplify your testing. Speaking of the last question, which was around verifying code, this is a very timely question and a talk. I want to bring on Khan, who's going to be talking about Sourcify and simplifying a lot of your needs on making sure your contracts are safe and easy to read and verified. So without further ado, please welcome Khan.
Yeah, thank you, Kartik. Hello, everyone. As Kartik mentioned, I will be talking about Sourcify and Sourcify verification. We at Sourcify also are doing source code verification, but more in an open and decentralized way. But we are actually more than that. We are also actually an initiative for more human-friendly contract interactions. And that's now I'll talk about how we can do this. So I'll start with just a normal day in Web3, just an example that you have probably all seen if you have been in Web3 space for a while. And it's this. So it's a daily thing now, although this has improved slightly, that every day we encounter interactions with contracts that we have no idea. So when you see this, this is like, what is happening? What am I doing? Am I talking to the right contract? Am I doing the right thing? And at the end of the day, this basically is the same thing as telling the contract, just shut up and take my money. I have no idea what I'm doing. And the good thing is we can change this. So it is a difficult task. It's a difficult thing, but that's what we are striving for. But as I said, a typical Web3 interaction nowadays is still a YOLO signing nightmare, what we like to call this interaction, signing on the wallet and just hoping for the best. And at the end of the day, what we want to achieve is something on the right instead of something on the left. I know these have changed recently in most of the wallets, but still we don't have really comprehensive messages that regular users or even the developers can understand easily. So let's dive into what you can do to achieve this. There are two sides of the equation. There are things that you can do as a smart contract developer and as a wallet developer. So let's dive into what you can do as a smart contract developer.
Hey, kind of just a quick interruption. If you're sharing a screen, we are not able to see it. So you might want to check that one more time.
Thank you.
There we go.
It works, right?
Yes, perfect.
Oh, okay. So these are not seen, I guess. Anyway, so let's dive into what you can do as a smart contract developer. First thing you can do is to use the NatSpec documentation. So the NatSpec documentation is part of the Solidity specification. It's part of the Solidity documentation. And it is rich documentation for functions, return variables, and it's a special form called Ethereum natural language specification. So it looks like this. It is similar to JS doc, if you are familiar with the JS doc. And you can find the NatSpec in your contract. It's mostly on top of the functions. It has a dev field, which is for the developer documentation, which then we have the notice fields for the user documentation. Then we have the documentation for the parameters. And the nice thing about NatSpec is that it supports dynamic expressions. What does it mean? It means that the fields you can see here, for instance, the old owner and the new owner of this user documentation can become this. So when you are showing the users the user documentation, you can fill these variables dynamically and instead show the values to the user. And even better, you can show something more human readable to the users if you have, for example, a reverse ENS name. Okay, so we know what user doc and dev doc is, but where can we find it? Where can we find and leverage these fields? These fields are in the Solidity contract metadata. I'm not sure, probably most of you are not familiar with the contract metadata. It is actually introduced in 2016 with the earlier versions of the Solidity, but it was actually not picked up by the community. So it is a JSON file generated by the Solidity compiler, which contains metadata, as the name suggests, but it consists of 4 main fields. Firstly, ABI, then user doc, dev doc, as we have seen in the previous slides. Then we also have the compilation information and the information about the source files. So the first 2 fields are concerned with how to interact with this contract, the metadatas, contract of the metadata. And the second 2 fields, the next 2 fields are concerned with how to reproduce a contract compilation. The file looks like this. It is a JSON file, as I told you, and it is, let me show it. I'm sorry, I can just hide this. Yeah. Oh, there we go. So it is a file like this. And in the output field, you have the ABI, DevDoc, and UserDoc. And you can see the NatSpec fields are embedded here. For example, the one we talked about, the NatSpec comment we talked about is here, replaces the owner, old owner with the safe, in safe with the new owner. And the other information here are, as usual, the compiler settings, the EVM version, the optimizer settings, the source information, and the source information also contains the content of the source file, although not always, and the hash of the source file. Okay, now we know where to find the DevDoc and UserDoc, but where's the metadata? Where can we find the metadata? Where can we find this file? If you use the Solidity compiler, it's obtainable with the metadata flag. So if you pass the metadata flag to the compiler on a terminal and the contract, you will get the metadata file. It is also available on frameworks. If you're using Truffle, after you compile the files, you can access the metadata. You can access the compiler artifacts actually. And in the artifacts, you can find the metadata in the JSON fields. If you're using Hardhat, it is also in the artifacts. And since Hardhat version 028, you can find the metadata of each contract in the large build file. And it's also embedded somewhere, embedded in your contract bytecode, but not the metadata itself, but the IPFS hash of the metadata file is appended to the bytecode of the contract when compiled. So the Solidity compiler by default actually embeds this information along several other information at the end of your bytecode, and this is also deployed to the blockchain. You can turn this off, but by default, actually, this additional field is appended at the end of the bytecode alongside the functional part of the code that corresponds to the contract we have written. And this IPFS hash of the metadata file acts as somehow as a compilation print or a digest of the whole compilation that you have done. And if you publish this metadata files, that means you can access it through its bytecode. So as we said, this is an IPFS hash of the metadata file. So if you get the contract bytecode and decode this IPFS hash, then it's available on IPFS if it's published or pinned by the author of the contract. There's actually a nice tool to see this in action that we call Playground. In here, you can go to, you can fetch your contracts, and we also have some example contracts here. Let's have a look at this. For instance, if we want to see the code, bytecode, and the metadata of the Ethereum deposit contract, it will fetch the bytecode of the contract. Then we'll decode this part, the highlighted parts, which corresponds to the fields that we talked about. And then if we decode this, we see there is IPFS hash and the Solidity version of the contract. And here, using this hash, the metadata files actually fetch from the IPFS. And we can see the metadata file here. Okay, so we use the NatSpec documentation. And the second thing we can do is the source code verification on Sourcify. So before diving into more, maybe let's have a look at what source code verification is. I'm pretty sure everyone has seen this green check mark if you are interacting with a contract or looking at the source code of a contract. And you see this and you're happy because then you know everything's verified, everything's checked, marked, and this is what you see in the Etherscan when you are looking for the source code of a contract. But how do we know that actually a random code on GitHub is not this actually correspond? How does it correspond to the code of this contract on blockchain? So if I give you this code, for example, how do you make sure if this is actually the code corresponding to the contract on blockchain and not just a random contract? So this is how it works. So we have the Solidity files, which are our source code. Then we also have the compilation settings. This is when you are compiling your contracts. This is just a default thing. And what we do is we take the source code files, then we take the compilation settings and we feed these into the compiler and we recompile everything. This is actually when the second part of the metadata file comes in handy, because this part gives us the information about how to reproduce a contract compilation. And if we have this in hand, then now we can make use of this and see if we can reproduce the whole contract compilation. So we get the source code files. If you are verifying a contract, you give us source code files, you give us the settings you have, then we recompile everything. Then the compiler outputs the bytecode of the contract, the code that the machines understand, not the human readable source code, but the bytecode that is deployed on blockchain. And then we also have the contract that we want to verify. For instance, if we have this contract at this address, then we get the code of this contract from the blockchain. Then we see if these codes match. So if these match, then it means the source code you provided in these slides and these settings are actually matching the contract on the blockchain. And in Sourcify, we actually have two types of matches. One is the partial match, when the bytecodes match. And the second one is the perfect match, as we call. This is when the bytecode plus the metadata match. And if you recall, the highlighted fields at the end of the contract bytecode, this corresponds to these fields. So when the black fields only match, that would be a partial match. But for a perfect match, you need the bytecodes to match, as well as the metadata to match. And if you recall, the metadata acts as a compilation fingerprint. That means if we have the metadata fields matching as well, the compilation as whole is exactly the same as the original contract. And yes, this will cryptographically guarantee the whole compilation is exactly the same as the original contract. So even the Solidity files are exactly the same, even the comments, variable names, even the white spaces are the same. And how does it work? So let's see in the case when something matches. So we again have the source code files. Then these files are hashed by the Solidity compiler. The compiler hashes it actually when you are compiling the contract. Then the hashes of these files are embedded in your metadata. So when we looked at the metadata file, we saw that the hash of the source files are also included. So the hash is embedded in the fields of this source file, and as well as the other files. Then the hash, the IPFS hash of this whole file is taken, metadata file. And then the IPFS hash is embedded and encoded at the end of the contract bytecode, as we have seen before. Then we see if the one on the left, the one we recompiled, is actually matching the one from the blockchain. And if it's matching, it's a full match. It's a perfect match, as we call. Now let's see what happens when you make a change, when you add a comment, change a variable name, anything. So again, we have the source code files, but this time a different source code file with a slight difference. And that causes the source files hash to change. then the hash in the metadata file will change, and consequently, the hash of the metadata file will change. Now we have a different hash. And this different hash will be embedded will be appended at the end of the bytecode. So the last field will also change. And this time, you will be having only a partial match, not a perfect match, but excluding the last part of the contract bytecode, this will give us a partial match. Okay, then now we know what source code verification is and how can you verify contracts. One way to do this is to use the Sourcify UI. We have a UI for you to verify contracts. You can here provide us with the metadata file as well as the source code files and give the contract's address and the chain. Then we can recompile the whole thing and see if it's a match. And we have several chains, I think at the moment, close to 30 different EVM chains that we support and where a contract verification is possible. We also have an API where you can provide the same information through an API programmatically. And we also have the documentation where you can see how to make use of the API. We also have extra tooling. For example, with the Hardhead, we have the Hardhead deploy plugin that you can easily verify your contracts after deploying. So if you have deployed a contract on mainnet, you can pass Hardhead network mainnet Sourcify, and this will verify the deployed contract on Sourcify. We also have a Remix plugin. If you deployed your contracts over Remix, you can easily pass the contract address and contract chain, and the plugin will verify the deployed contracts. We recently also have the Foundry support. So using Foundry, now you can also verify the contracts by passing the verifier flag and Sourcify. This will also verify your deployed contracts on Foundry. We also have a nice feature called automatic verification, also as monitoring. So this, as the name suggests, automatically verify the contracts that are deployed on the blockchain. So I'll do a short demo about this. So here on Remix, I have a simple contract called storage sol. And this contract itself, as well as its metadata, is already on IPFS. So I'm going to deploy this contract on the Girly test network. Then we will see how the automatic verification actually works in action. So we are waiting for our transaction to be mined. Right, so our contract is deployed. So I'm going to Sourcify and I'm going to check the contract if it's verified on Sourcify. It is currently not. So this makes use of the IPFS hash that is deployed, and it listens to the blockchain for new contracts on the blockchain. If it finds a new contract, then it will check the metadata at the end of the contract, then tries to pull every information, all the source files and everything, then it will do a recompilation itself. So this should actually work in seconds. So yeah, as we can see, the Sourcify monitor has captured this contract creation and automatically verified the contract because the metadata file was already published on IPFS and the source file was already there on IPFS. Yeah, currently this is only done for the Ethereum mainnet and the testnets. And yeah, this automatically verifies the files. So that means actually the second step was the source code verification on Sourcify. Then it actually becomes publishing metadata and source files on IPFS. So you don't even have to go to Sourcify and verify the contracts. The only thing you have to do is publish your source file as well as the metadata in a reasonable amount of time. So it has to be done when the contracts are deployed. We have a buffer, I guess, around 5 to 10 minutes. So you have to publish that 5 or 10 minutes after the deployment, or even before, maybe. And this is only done on the Ethereum mainnet and testnets. So we also have the contract repository, which is both served over the HTTP and IPFS. So every file that we verify, we serve also on the IPFS for the later fetching. And it is under an IPNS name with a DNS link under repo.sourcify.dev, and it's updated every 6 hours currently. So you can also see it here. Right now, I'm showing the repo.staging sourcify.dev because the main server has just got an update, but it will be also available in a couple of hours. So you can also here download the whole repo or explore the repo, how the contracts are structured. So we have the contracts, we have the full match. Then we also have the contracts sorted by chain ID. But I guess this is taking some time to load. Yeah, IPFS is not always the fastest network, unfortunately. But most of the time, if you want to search with an IPFS hash, that works pretty well. Okay, so these were the things that you can do as a smart contract developer. Now there is the other side of the coin. What can you do as a wallet developer for your users? So again, remember the first two fields of the metadata file. They were concerning how to interact with the contract. So these were ABI, user doc, and dev doc. And as a wallet developer, what you want to do when your users are talking to a contract, you want to decode the contract call, which is in bytecode, and show your users meaningful message. So what you want to do is get the user doc and decode the ABI on contract interactions. And for that, remember what you need is the metadata file, because the metadata file contains the ABI as well as the user documentation. So what do? You fetch the metadata from Sourcify's repo, right? No, please don't do that, because actually the information you need is already there. So you don't even need Sourcify to do that. You already have the IPFS hash of the metadata file on the contract bytecode. So what you should do actually is to get the contract bytecode, fetch the metadata with IPFS hash, because remember and in this field, you can get the IPFS hash of the metadata file, then fetch it over IPFS. Then you have the ABI and the user documentation. Then you can show the users more human-friendly messages. So using this information of a verified contract, you can actually show something on the right instead of something on the left. So our way of human friendliness, so to say, is just one way. So we make use of human readable descriptions with not spec comments in the metadata, but there are more ways to do that, to achieve this. For instance, there is the EIP 4430 and EIP 3324, which where the idea is to have a describer function inside the contract, which when they are called, it returns a human readable description and then runs the function that is called. So the advantage is that it can decode things like an ENS commit, but this also means you have to have extra data in your contract that is deployed. There is also a recent EIP draft by Dan Finley. There, the idea is to give the user the information about the contract on the first point of contact. So when you, for instance, visit uniswap.org, then you will receive the API and the method describers from the website. Then this will be saved on your wallet. The nice thing about this is it's backwards compatible and it's flexible, but it's not bound to the contract itself. Yeah, and also apart from being human friendly, there are many more ways for a better UX. So you can decode the contract calls. You can warn the user if they never interacted with the address. You can say if the contract is verified, block if the known scam address, if there is a large amount or if there are large fees with the amount. Additionally, you can show the users how many times this contract was interacted with, because a quote unquote safe contract will have more users, and a scammer would maybe have a less interactions. And when was this contract deployed? An older contract is probably more legit. And as well as if this contract is audited, if it's by whom it's audited. So there are a lot of things actually we can do, and we can do better. So let's have a recap. What is Sourcify? Technically, we are an open sourced automatic smart contract verification service. We have a user interface, an API, and tooling to verify contracts. We also have a public decentralized content address storage of verified contracts for everyone to access. And more generally, we are an initiative. We act as a base layer and public good for other tools to build on top of. An initiative to foster the use of the contract metadata, NatSpec, and full verification. And we are also an ongoing effort to improve smart contracts UX, safety, and transparency. So thank you very much for listening. And I would be happy to answer questions if you have any.
Thank you so much. I'm looking at the Q&A. I don't think we have any that are specific to this, but people want to be able to kind of see the slide deck. So if we're able to also share that with us, we'd love to make, I'll just, there you go. There you go. So I'll be able to kind of relay that to the audience, and then also we'll be able to put the links up. But this was really good. Sourcify is getting better and better. We've seen this happen, this talking about Sourcify every kind of few months to in the past year, and you can see the massive improvements, and that's awesome. So thank you so much.
Thanks for having me.
And with that, we are a little bit behind, but also we're ready for our next talk. And I want to thank you so much, Count, for talking about Sourcify. And without further ado, I'd like to welcome Ari to talk about everything that's happening in the Solidity ecosystem. So welcome back after our last year's DevTool Summit, and excited to have everybody also learn about all the things that are going on in Solidity.
Am I audible?
Yes, you are.
Perfect.
I'll let you take over from here. And we can see this. Looks like you are now on mute. I'll just ask you to check for that setting one more time.
Yeah, I know what.
There we go.
Okay, perfect. Is that better?
Yes.
Yeah, I would like to start the talk with a question to the audience. It usually works better when there's a live audience and when people can shout the answers, but I'm still trying it here. So the question is simply like, what is the most requested Solidity feature since the last 2 years? You can just like type your answer in the chat or wherever you want. I'm gonna have a look at it later. And we are also gonna talk about it in the second part of the talk. Until then, let's forget about it and talk about the next thing, which is a very simple way to do something in Solidity. So typically, so you have an interface. Here it is a ERC20 interface that only has a single function, transfer, because that's all you want in this case. You want to like encode a call. So how do you do this usually? So since the beginning of Solidity, we had this feature called ABI.encode with signature. And this is very useful for like doing this thing. The syntax is very simple, ABI.encode with signature, and then the signature of the contract. And this has been around since the beginning of Solidity, perhaps. But this is bad in many ways. And why is it bad? It's actually not typo safe. What does that mean? So here is the same thing, but with like 2 typos. One is a space after the comma, and the other one is uwint instead of uwint 256. You can see uwint 256 here. And this actually leads to a different encoding of the call data, and this is really bad. And moreover, imagine if you actually change something here, maybe the function, maybe the types, it doesn't really get reflected over here. So this is like a feature with a lot of foot guns, and we have to really rethink if we should really do this. It turns out there is a better way to do it. So let's look at abi.encode with selector. So it's pretty much similar to the last one, except that you use abi.encode with selector and you have to make a reference to a function. So in this case, it's minimal erc20.transfer.selector, which would like automatically put the 4 bytes of the selector here, and then you can encode with the to-end value, which is the parameters. So even this is not very good. And why is that? It's actually not type safe. The problem here is that, okay, imagine if we actually use a uint parameter instead of an address in the abi.encode with selector. It actually compiles and it will give you probably a different answer depending on what the value of 2 is. So this is also bad. We shouldn't do this. Is there a better solution that actually fixes both these issues? Yes, there is. And that is the abi.encode call. So this is both typo safe as well as type safe. So how does it work? It pretty much works exactly like the last 2 ones, except the name, abi.encode call, and then a reference to the function. Here it will be like minimal erc20.transfer, and then the parameters as a tuple. So if you make a typo here, the compiler would complain. And if there is a different type instead of 2, let's say uint, the compiler would complain. So you don't have to worry about like shooting yourself in the foot. So as I said before, it's type safe and typo safe. You can avoid a lot of foot guns. It's available since 0811. And in retrospect, we have to even, these 2 features, we have to even think if we should even put this in the language anymore. We have to probably deprecate it at this point. And it's already in use currently. Here you can see Alex's contract, which is doing like a deploy of Knossos saves on chain, and he's already using abi.encode call. And you can use it too. Okay, let me go back. Perfect. So what can we do next after we have abi.encode error? So as you might already know, like in the last year or so, writing tests in Solidity has become incredibly popular because of like DAppHub and now Foundry. And this pattern comes up quite often, which is Foundry has this idea of expect reward, which is you want to make a external call and you expect the call to revert with some bytes. As you might already be using, as you might already know by now, Solidity has this idea called custom errors, which allows you to have properly encoded errors instead of just strings. It's more gas efficient in most cases, and also just more elegant. So what you can do to test this would be something like vm.expectReward, and then just put whatever data you are expecting to reward. And this is an example from OpenSea's new contract, Seaport. So if you look at how they are doing it right now, it's abi.encode with selector with the signature of the error and then the parameters. So recall that errors and functions are encoded identically. So you can actually reuse a lot of things that are done for functions, also for errors. But we can actually do better here. You can actually introduce something like abi.encode error with similar semantics to abi.encode call. We don't have this implemented right now, but there is an issue and there is somebody working on implementing it. So you can very likely expect it to land in the compiler soon. So this is how the same code would look like, which is again type safe and typo safe and just more elegant. Yeah, so now let's go back to the question from the beginning of my talk, which was what is the most requested Solidity feature, perhaps for the last 2 years and even more. And you can look at the results, and a lot of developers have made in the survey. And there is one thing that really stands out, which is fixed point arithmetic. And that is indeed the most requested feature for Solidity since ages. So before we talk about like what's happening, I want to make an introduction to like fixed point arithmetic. What is even fixed point arithmetic? Effectively, you can think about it as working with fractions or floating point numbers. Although the use of floating point number is a bit of a misnomer, but you get the idea. So typically you start with a base, we call it B, and this is going to be, for example, 10 raised to 18. 18 is typical. 18 is a good typical number because ETH has 18 decimals. One ether is 10 raised to 18 way. So you represent a number P by, in real terms, P by B by storing it as P. So as an example, if you have one way, which is actually the fraction 1 by 10 to the power of 18 ether, you store it as 1 instead of like 0.0 as 1. So the number 0.000 like 18 times or 17 times, then 1 would be represented as 1 in the EVM. And the way to interpret this would be by thinking about it as like 18 decimals. So you are already implicitly using this if you are interacting with the ERC20 token, for example. They have this innate idea of decimals. For example, in USDC, it is 6, in DAI, it's 18, and you don't really, you just like add them like any other numbers. And that's my next point, which is addition and subtraction requires no change. You just add, you just subtract. It's exactly the same. But the next thing is more interesting. Multiplication and division, they are entirely different now. So if you want to multiply two numbers P and Q that are in stored values, I want to make this distinction of like stored value and like the actual value. Like the actual value would be P by B and the stored value would be P, remember. So P times Q in this case would be equivalent to P times Q by B. You can like try to work your way to like this calculation, but this is how it works. And similarly for division, if P and Q are stored values, the actual stored value for P by Q would be P times B by Q. So this is fixed point 101. Now let's talk about some like history of fixed point arithmetic and why doesn't Solidity already support it. So Solidity has the type uFixed and fixed for a very long time, and also in the ABI. So uFixed stands for unsigned fixed point arithmetic, fixed point type, and fixed stand for the signed, just like uint and int. And what do I mean by it's in the ABI? I will talk about it later. But just remember that it's in the ABI already. But these types are actually unimplemented and therefore useless if you actually try to do anything with it. You would get a compiler error if you actually end up using this somehow. But many of the programs you can compile, but without being able to do anything with it. Yeah, so going back to the question, why don't we have it? We were pretty close to like merging a lot of things into the language, but in the last minute we decided no. And one reason is because it's such a contentious issue. There are multiple different implementations. and there is no consensus in the community on like how this should look like. To give an example, there are multiple ways to implement fixed point types. One is you can ask the question, should it be decimals or should it be binary? And how many decimal points? 18, 20, 24, or 6? And there is this third point, which is very interesting. I would like to call it the shadow overflow, or some people call it the phantom overflow. So remember that this is the most basic calculation, P times Q by B. So P, Q, and B are 256-bit numbers, but the multiplication P times Q may not fit inside 256 bits. But there can be cases where P times Q by B is a 256-bit number, but P times Q is not. And how do we handle the situation? Like, should we revert? Should we actually do the computation? There are people who say that we should revert. There are people who say we shouldn't revert and actually do the computation in a painful manner. And this also like brings the question of like gas efficiency. Like if you're doing reverting early would be easy, but whereas actually handling the shadow overflow is much harder. So let's now look at how many protocols implement fixed point arithmetic. One of the most famous example would be perhaps the VAD introduced by Maker, as far as I know. It is actually decimal. It uses 18 decimals, in fact, and it reverts in the case of shadow overflow, which is, if P times Q is, it doesn't fit into 56 bits, then it's going to overflow. And it's relatively gas efficient because the computations are very simple. A modern implementation of this can be found in like Solvmate. So you can see the reward happening here, for example. So let's go back. Okay, perfect. Yeah, so to summarize, it's 18 decimals. It's decimal, not binary. It's relatively gas efficient, and it doesn't care about shadow overflow. It will revert early. And the next example is in Unisat v2, which actually uses a binary fixed point type with, it's actually 112 bits, not 122, it's a typo. And it actually uses shifts instead of division, where shifts are actually cheaper in the EVM than division. Shifts are 3 gas and division is 5 gas. So there's a very minor efficiency improvement here, and it actually doesn't care about shadow overflow at all. Like, it turns out that this overflow case would never happen, and they ignore it. And it's very gas efficient because, first of all, you use shifts, and second of all, they don't care about this intermediate overflow. Now going back to Unisat v3, this is where things actually get very interesting. As far as I know, they use binary fixed point, but they use something called the full math. And the full math is a very, very interesting function, originally implemented by Remco. So you can see this like very interesting piece of code with a really complicated math. What they're doing here is trying to get rid of this shadow overflow. So in the case where P times Q overflows, but the value P times Q by B is well defined, Unisat v3 or the implementation by Remco still manages to compute the actual number. And this is very impressive. But unfortunately, there are a lot more checks, and there are more complicated arithmetic operations involved in this computation. And that means there is more gas. So we saw like 3 different implementation: the VAD math, the Uniswap v2 binary, Uniswap v3 fixed point. I mean, Uniswap v3 with binary and the full math. So the question you ask is, which one do you implement? The Uniswap v3 is perhaps the most canonical implementation, but unfortunately, it is more expensive than the other simpler ones. So can we find a better solution than this? Probably we can. So remember that the key computation here is, the key computation here is P times Q by B. And if we can compute this value in full precision, we can actually do the Uniswap v3 full math implementation cheaply. And we have this proposal for a new opcode in the EVM, which is called Maldiv, which actually does this computation. So it's going to perform P times Q by B in 512-bit arithmetic, but in the end, it truncates it to 256 bits. So where do we go from here? So first of all, it's not clear to us if fixed points as a type should belong to the language, but we want to have like very good support for fixed point arithmetic in the language. And one way to do that is by allowing users to build their own types and operations on the type. And the first step towards this is already there, which is user-defined value types. So you can try to implement your own type. In this case, it's fixed 18. It's exactly like UN 256. And more importantly, there is no change in the ABI. So the ABI is going to be exactly the same as if you use UN 256, but it's more type safe. I mentioned before, I will talk about ABI issues about UFixed. So the type UFixed actually exists in the ABI, but this wouldn't have the same selector as the real transfer functions. So this means that the UFixed, which is already present in the ABI, it doesn't have any backwards compatibility. So if you want to try to interface with, let's say, DAI or USDC, DAI would have 18 decimals, USDC would have 6 decimals. This function wouldn't even be calling the right one. Whereas if you use fixed 18, it actually has exact ABI compatibility. So this is the very first step towards fixed point types in the language. And the second type is to implement Maldiv in the EVM, which is probably going to take another like hard fork in the EVM. And the third step is going to be implementing operators for fixed point types. This can be done in whichever order we want. So just to give an idea of like how operators would look like. So here is how the checked multiplication in fixed point numbers would look like if we have Maldiv in the EVM. So I didn't mention this, but there is an exceptional case in the Maldiv, which is around 0. So the EIP currently proposes a special case for Maldiv AB0, where the 0 would be treated like 2 raised to 256. And the goal would be that this is going to help with checked fixed point multiplication. And this is an example of how it would look like. Here you're using like fixed point 8, user-defined fixed point 18, and perhaps a syntax like this, using checked mul as star for fixed 18. And then your user-defined fixed multiplication can be used anywhere in the language. So what can you do now? So the Maldiv EIP is still, it's a relatively new proposal. We want to get as much feedback as possible. For the EIP, feel free to talk to us. We want especially to get feedback about the exceptional behavior around the value 0. So that is Maldiv AB0 is treated in a special case. There are ways to get around it. You don't really, you can treat AB0 as 0, but then there is like more gas to actually deal with this truncation, detecting the truncation case. The third thing is, of course, we want to see if there are other uses for Maldiv, especially for implementing cryptographic operations. Perhaps you want to implement EVM inside EVM. Then you might need to calculate, for example, mod, malmod, modx, things like that. Would that, do you see a use case for Maldiv in any of these other applications? Let us know. And of course, we would like to get your feedback on the syntax for user-defined operators. So I mentioned how the using statement is currently being, I mean, this is not currently implemented, but this is the current proposal. So we would like to get feedback on how this looks and how this implementation feels to you. And lastly, you can find more notes about fixed point arithmetic in this HackMD. I will be linking. Oh, here is the link to my talk, and that's it.
Amazing. Hey, I'm not Kartik, I'm Jacob, just kind of jumping in as Kartik works on some stuff behind the scenes. Awesome talk. If anybody has any questions, feel free to drop them in the channel, and I will surface them over to Harry. I guess I had a quick question. It's sort of, I guess, related a little bit to the topic. Like, I know just from my experience programming with floating point and different implementations in different languages, precision comes up a lot as a potential issue. And given that, like with blockchains, we're writing contracts that are largely dealing with money and that kind of thing, I kind of curious like what your thoughts are about like being able to both come up with great specifications for floating point, but then also like teach people on the risks of precision when it comes to dealing with these primitives.
Yeah, that's a very good question. I mean, so when dealing with decimals, there are two approaches. One is fixed point numbers. The other one is floating point numbers. Floating point numbers are incredibly popular in like usual computations because they are very fast to implement. Most processors have some instructions to deal with them. But the issue is that it can be a little bit counterintuitive to understand it. And also there's floating point errors. So if you look at historically, maybe like 20, 30 years in the past, the equivalent of like maybe this 500 million smart contract hacks would be rocket failures. So a lot of these rocket failures can be traced to bad floating point implementations, or how people did not, or how the accuracy of some numerical computations went. I mean, some numerical computation did not end up being accurate enough because of this repeated floating point errors. And hopefully, like the fixed point arithmetic makes this a little more apparent. So the issue with floating point errors is that almost every floating point operation, it has a error associated with it. So if I go back, addition and subtraction, it has a small error in floating point implementation, but in fixed point implementation, there is none. Similarly, in multiplication and division, there is an error term. In division and EVM, there is an error term, but other things like addition and subtraction and multiplication, there wouldn't be any errors in fixed point implementation. So first of all, the answer is we think fixed points are the way to do it. But of course, if you are introducing division, there's going to be errors, and you would need to have some understanding of rounding issues, unfortunately.
Yeah, and then hopefully those don't trickle into too many really bad outcomes at some point on the line. Awesome. Okay, great. Well, actually, I think Kartik is actually back from behind the scenes, so I'm going to invite him back on stage, and I will disappear, and I'll let him wrap us up. But thanks for the talk, Harry. I really appreciate that, and learned a lot about how the team is thinking about implementing these primitives.
I was just away for a brief break, but I did watch the rest of the talk. So thank you so much, Ari. This was a great review, and I feel like we gotta get you more here because oftentimes there's a big feedback loop that we get to close when we work with thousands of devs trying to figure out how to do more interesting things with Solidity. So this has been really helpful, and thanks for also linking to the slides, because that's the most common question we get, and how do they catch up on the slides? And we'll share that with everybody else.
Perfect. Thank you.
Really appreciate it. So that was Hari talking about all the stuff that's happening with Solidity. And up next is Tom. And I'm super excited for this talk because Tom is going to talk about WalkMe. This has been a tool and an SDK that I've been using more and more personally too. And I can't wait to have Tom share about some of the internals and what's possibly next. So without further ado, let's welcome Tom.
Hey everyone, super excited to be here. And I'm gonna talk about getting started with WalkMe. This is the first time I've publicly talked about WalkMe, and I'm like really excited to share how to get started, maybe some more advanced details and ways to use the library, and then talk about sort of what's coming up next on the roadmap. 1 second, I just have some stuff on my screen. Trying to move the Zoom stuff out of here. Okay, so yeah, I'm Tom. I'm the author of WalkMe, currently a front-end engineer at Mirror, and you can find me on GitHub and Twitter at these handles. What we're going to talk about today is maybe a quick overview of WalkMe for those who aren't familiar, walk through an example of how to get started quickly if you're working on the hackathon or a side project. This will be helpful for you, and then some pro tips and things that people aren't always super familiar with when they get started using WalkMe, but they'll help save you some money with RPC clients, make it easier to develop dApps, and move quickly when you're building. And then lastly, we'll just go through a little sneak peek of a feature that I'm really excited about and should help everyone be more productive. So yeah, if you're not familiar with WalkMe, it is a React library for Ethereum. Takes a bunch of commonly used functions, patches them up into hooks, so that way you can use them for a variety of different things. Initially released this on January 4th of this year, and since then it's grown quite a bit. A bunch of projects have adopted it, from ENS Foundation, SushiSwap, Stripe Crypto, a bunch of others. And it's been cool to see lately some folks building developer tools on top of WalkMe. So if you've seen RainbowKit, ConnectKit, or ThirdWeb's SDKs, you know what those are all about. WalkMe itself is great, but what these folks have done is took the library and added their own twist and abstraction on top of it to make it really easy to connect a wallet, deploy and interact with smart contracts, and similar things. So you should definitely check those out if you're not familiar. And yeah, I mean, it's grown a lot. So quite a few GitHub stars and downloads per month now, and hopefully we'll keep growing as we add more stuff that people are excited to use. And here's some quick links if you want to check it out as I'm discussing, or if you want to check it out later. Doc site. We don't have a Discord. Everything is mostly done asynchronously on the GitHub repo, so you can check it out there or follow us on Twitter to get updates. So yeah, right now WalkMe has 25 plus hooks dealing with things like wallet connection, ENS information, interacting with contracts, signing data, and sending transactions. So I just highlighted a few here. Use Connect is really great and quick way to connect wallets to your application. Use ENS name is really good for fetching an ENS name for an address. We have this hook called Use Contract Reads, which behind the scenes does multi-call, and which will save you a lot of money on your RPC requests, and falls back to just regular reading if the chain that you're using doesn't support multi-call. Sign message is useful for signing basic messages with personal sign, but also if you're trying to do anything with sign with Ethereum, you should check that hook out. And then another really cool hook is use wait for transaction, which you can pass a transaction hash to it, and it will update the status as the transaction goes from submitted state to the network as it's mining, and then as it's confirmed. So that way you can show some updates to your users, and we'll talk about that one a little bit later. But WAGMI isn't just about hooks. It does actually quite a bit more. There's built-in wallet connectors for MetaMask, WalletConnect, Coinbase Wallet, injected wallets. These are the most popular, covers most of the use cases people have. There's been some community-led efforts for additional connectors, like Gnosis has worked on and has a separate NPM package you can install for their connector. And it's exciting to see people add more and more. So that way, if you have different use cases or want different wallets to be supported, all you have to do is extend an interface and implement a few methods, and you're good to go. There's also quite a bit of caching and request enhancements that we released a few months ago. So this way, like if you don't have to run into situations where you're spamming your RPC, something like Alchemy, so you can keep your bills down. And make sure stuff is like pretty snappy and fast for users. So if you fetch their ENS name once and they come back and reload the page later, they'll automatically be there, so you can use it. We also do some things where we're able to automatically update data as wallets change, as blocks are mined, and as users switch around and use different networks in your application. The other really cool thing that some people have been playing with lately is WAGMI has a vanilla JS client. So mostly people interact with the React hooks, but what you'll see in a moment as we go through the quick start is there's a vanilla JS client you can use, which allows you to use WAGMI in instances where you aren't using React, if you're trying to use it outside of the React tree, or if you want to use it with a different framework like Svelte or Vue or something like that. And another interesting thing that you can check out in the repo is WAGMI has a full test suite running against Ethereum, which uses Anvil behind the scenes to spin it up. So if you're interested in testing your dApps, WAGMI has a connector which will you can set up to use Anvil or Hardhat or something like that, just to make sure that when you're deploying things, everything out there is working. So move on to go through how to get started with WAGMI here. So the first thing you want to do is install WAGMI and Ethers. You can do this inside of an existing project or a new project when you're getting set up. This example uses PNMP, but you can use NPM, Yarn, or anything like that. I've set the versions here explicitly, so that way, if you're trying to follow along later, you make sure you're using the same version. WAGMI hasn't hit 1.0 yet, and there's been some API changes over time as we move to get to 1.0, just so we can make sure the developer experience is getting better and better. So if you're following along with this later, just make sure you're watching what versions you're on. So yeah, once you install, we'll just create a client. This is the vanilla JS client I was talking about earlier. The only option that you need to provide out of the box is the provider, which is just an Ethers JS provider. WAGMI is built on top of Ethers. And so by supplying a provider here, you make sure the WAGMI client can connect to the network. And the other thing that I've added here is auto connect true. Most people probably want to set this on. And what this does is allows whenever someone refreshes your app, if they're connected with their wallet before the refresh, or they come back later, they'll make sure that the connection is restored. So that way they don't have to sign back in when they reload the page. So yeah, you create your client and then you wrap your app in a context provider. So you just import WAGMI config, which React context provider, pass the client there, and then you're good to go. You can just start using the hooks. Like I said before, there's a bunch of them. Here's two of them as an example. Say we have a profile component and we want to render out the connected wallet address, and also optionally we'll fetch the ENS email when address is defined. So yeah, it's pretty easy to get started, and most people should be able to add this into a new app right away. And if you have an existing app, something like Web3 React or use dApp, it shouldn't be that hard to migrate over. So here are some pro tips I wanted to walk through. The first one is setting a chain-aware provider. So what this means is before, you can see we just had a static provider added here. Get default provider is an ethers method, which has a whole bunch of RPC providers behind it and sets it up so it's automatically on mainnet. And what you want to do is make sure your provider is initialized with a chain ID. And so the create client provider function has a chain ID argument that then you can pass into your provider. So that way, like if you're connected to one chain, let's say VNet, and then you switch to Optimism, the underlying provider, which WAGMI uses to fetch and update data, will then be on the right network. So yeah, in this example, I'm using Alchemy provider, just passing it the chain ID. And now that's chain aware and it's good to go. And what this means is when you're using hooks here, by default, so I'm using this use contract read hook. By default, this will read on the chain that the wallet is connected to, but you can also set it to read from a specific chain if you want. So this is only going to be making requests for a mainnet. So it's set to chain ID 1. The next pro tip here is for configuring chains. So it ends up becoming, if you have a multi-chain app, it becomes unwieldy to, in your provider function when you're creating your client, to like make sure that you're using the right providers for certain chains. So like, for example, in this case, for mainnet, I'm trying to use Alchemy. For Optimism, I'm trying to use Infura, and for Optimism Burley, I'm trying to use Alchemy again. And this is like a super contrived example, but sometimes you do want to use different providers for different chains. Either an RPC provider doesn't support the chain that you're using right now, or you want to use a different RPC provider, maybe a different API key for an RPC provider for like a test network or something like that. So you could, go about doing this in sort of the way that I have out here. You probably clean it up a bit, but instead of that, we created this API called configure chains. And what this allows you to do is specify a list of chains that you want to use ahead of time. So in this case, mainnet, Optimism, Optimism Gurley, and then a list of RPC providers that you want to use. And what's great about this is a couple of things. One, it spits out all the chains that you passed in, a provider object and a WebSocket provider. But what it actually does is it takes the RPC providers you've listed out and it creates them in like a fallback ethers provider. So that way, let's say Alchemy goes down, then it will fall back to the public RPC provider. So this is really good because sometimes, RPC providers go down, Infura will go down, and you can fall back to Alchemy or vice versa. And it will set this all up for you. All you have to do is put them in order that you want them to be used inside of the second argument of configure chains. And then, like I said, instead of having like a provider or WebSocket provider function block where you're having to list out a whole bunch of different cases, here you can just pass the results directly there. And similarly, you can take the chains that is spit out from configure chains and pass it to any connectors that you're trying to set up. So in one go here, I'm able to set up MetaMask, set up my provider and WebSocket provider. And all I do is call a function telling it how I want it to be set up. That's configuring chains. So another tip that touches a little bit on React and can help with performance in your application is using account callbacks. So use account as a hook that shows the current address, the connector, and some other like flags on whether or not you're connected. And something that a lot of people commonly do is if they want to check to see whether someone's logged in or logged out, if their wallet's connected or disconnected and how that state changes, they'll just use a effect from React and they'll manage all this on their own which if these can start piling up, you could have like, a bunch of these in your app if you're trying to constantly inspect whether someone's connected or not. But what you can actually do instead is use account has these built in to them. So there's on account and on disconnect. And whenever these fire off, whenever these change, you'll be able to use that data instead of having to manually track this on your own. So that's a pretty useful one to get started with. The last pro tip that I wanted to go over is the transaction lifecycle. So likely if you're doing something in your app, once you've connected your wallet, you might want to be sending off transactions to the Ethereum network. And so this sort of follows 3 steps. The first is preparing your transaction. What this allows you to do is set up the request you're going to be making. Maybe you have some arguments that you want to have set up. You have like a minting site or something. And what this allows you to do is once the user hits like mint, by preparing the transaction, you've already done some of the computation ahead of time of what the wallet is going to receive. So that way, on the second step, send transaction, you'll see a prompt right away. And so you'll be able to confirm and submit that to the network. And then last year, once you've sent your transaction to the network, you can wait for the transaction. I was talking about this a little bit earlier with the use wait for transaction hook, which allows you to sort of watch as the transaction is mining, maybe show like a view on Etherscan or view on Block Explorer link while that's happening. And then once it's succeeded, you can show a link to the Block Explorer, show a confirmation state, that type of thing. So what this sort of looks like is you use the use prepare contract write hook. Here, you pass in an address for your contract, the contract interface. So here's a basic example of mint, function name, and then if that function has arguments, you can pass those into. So what this will do is once this component mint NFT loads, it will take this data, format it into a request, which can then be sent off to the network using use contract write. So this just takes that config that's returned. And then once the user clicks mint, presses the mint button, write will send it off to the network. And then as it relates to waiting for the transaction to confirm, what you can do is use the use wait for transaction hook, and it takes a hash from use contract writes data. And then you can use is loading, is success flags, along with some additional information that isn't pictured here to show some different states to users of your application. So that's sort of like the steps that you want to walk through when you're doing this. You want to prepare the transaction, you want to send it to the network, and then you can optionally, but probably best practice from UX perspective, make sure you're showing the status of the transaction, whether it's loading, if it's succeeded, or if it's failed. So lastly here, I wanted to go over a quick sneak peek of something that I'm really excited about. I think it's going to make it a lot easier for folks to work on their apps, make sure everything is more safe and easier to get started working with contracts. So what this is some ABI type inference. There's great tools out there, one of them TypeChain, which you can use to generate types at compile time. Yeah, it's just CLI tool you can use based on your ABIs. But something that's coming to WAGMI soon is the ability to just use the TypeScript compiler to automatically provide like static typing for your different contract ones. So this is using use contract read, but you can imagine the same concepts being extended to use contract write and all the other contract interaction hooks. So here's an example. I have this ABI here, which has 2 functions, one that is owner of, one that is balance, has some inputs and outputs associated with them each. And then you can see that use contract read, takes in the function name and some arguments as well. And this is all actually typed right now. So if I, misspelled owner of, what happens here is I get some feedback from TypeScript that says owner of is not assignable to, and then it tells me the correct ones. So I can change it back here. Works similarly well for arguments. So if I made this a string instead of a number, then I get some feedback too. You know, if I, just to show you that this actually is working, if I change this to string, then it is valid. If I change this to an address, you can see here that it doesn't follow like the address format. So that doesn't work. And then similarly, like, you know, one of the greatest things about TypeScript is the autocomplete that you can get in development. So you can see here that all my function names are auto-completed. If I'm working on arguments here, you can see that these are typed as well. With the library we're using here too, which we wrote for this specific case and we'll be open sourcing as well. It works for a lot of complex types too. There's like 100% coverage here of the ABI spec. So like if we changed, let's say we change this input value here to a tuple type, just do this on the fly real quick, which just follows the ABI spec. So we can grab, let's just grab this, we'll grab address here, and we'll grab, actually let's grab owner. What we see here is components up, forgot a comma. All right, so now this function needs to have a tuple as an input. So we see here that, oh wait, these are both the same. So let's change this to token ID, can make it uint 256. All right, so now we see that the arguments need to be owner and token ID. So we can go ahead and add those in. So owner and token ID, and we're good to go. And so this works even on the arguments inside here, the type reference, and also we can have like deeply nested tuples. Another cool thing, if we switch this over to balance of, we have fixed support for fixed length arrays. So I can make this input an address of fixed length array of 2. So I can add in here. I only have one address, so you know it says requires 2 addresses. So now if I add in another one, if I add in too many, you know, it gets mad at you. So all the same stuff. And then other cool stuff here is the response type data is also typed. So if I change balance here to an array, then you can see that the data here is an array of like a number or big int return type. So yeah, that's the ABI type inference stuff. Super excited for this to come out. It's going to be a great way for people to add end-to-end type safety to their Ethereum applications. And yeah, works for overloads, follows the contract ABI spec, all these good things. Oh yeah, end-to-end type safety for contract interactions, make it really easy. This way you don't end up deploying a change where you've misspelled the function name or sent an argument in the incorrect format. Covers the entire ABI spec with TypeScript. There's an open library that we wrote for this that'll be open source, so you can use it in your own apps. You don't have to just use it with WAGMI. And supports, more complex types like fixed length arrays, tuples with keys, addresses, any combination of these things. Also supports function overloads, stuff like that. So yeah, you can keep on the lookout for that. Very excited. Hopefully we'll be releasing that soon. And lastly, I just want to say thanks to ETH Global. it's pretty awesome that y'all are doing this. And then also huge shout out to Family and Context, who are two of the GitHub sponsors for WAGMI. And then lastly, if you're interested, Gitcoin GR15 kicks off next week. So you can go to wagmi.sh/Gitcoin if you want to support or check out what's going on for that. And that's it. Thanks for tuning in.
Amazing. Cool. Thank you so much, Tom. And this was great. That's a pretty amazing preview on Catch the Autocomplete. That'll save all of us a lot of time. My obvious question is when?
Yeah. Yeah, exactly. Yeah, probably not going to commit to a certain deadline, but yeah, definitely looking forward to getting this out as fast as possible. Yeah, I was just on vacation for a couple of weeks, so.
Okay, so in the next 2 to 3 months.
Yep. Yeah. Oh yeah, definitely.
That's great.
Definitely.
Amazing.
Yep.
And maybe another one would be that obviously the library has become such a kind of rapid sort of integration into a lot of the new apps recently. I'm curious, like, what are some of the most common questions that you get in terms of feature support requests or just kind of patterns that you would like people to sort of take away, given that everything is still largely malleable?
Yeah.
How should people think about using the library in terms of best practices or things that you may consider in the future or would not consider in the future, and just getting some clarity around that would be great.
Yeah, totally. Yeah, I mean, the first thing I'll say is just because everything is still so early as it relates to the library, there's still, stuff we're figuring out, edge cases people might run into. And so I would encourage anyone that's using the library and runs into an issue or feels like something is like a little bit of a sharp edge to like drop a note in like the GitHub discussions or create an issue, just because like we take the feedback to heart and really want to make things very good. Another thing is a lot of people like want specific hooks for things that you can actually already do with like the contract related hooks. So people want a hook for like reading NFT balances or like, setting a token allowance. You can actually already do these things. Maybe it's not quite as obvious, but if you just pass in an ABI and a contract address, you can just, call a function and go right ahead. I think once we have the type inference, it's going to make it a lot easier for people to get started with those things. So
I feel like no, that makes a lot of sense. Yeah, I feel like the abstraction here is like the hooks piece, not the ability, right? And the fact that you get to use it easily is kind of the aim with React hooks.
Totally. And then one other thing I'll mention too is like this is all starting with React, and we're definitely very focused on React right now, just to sort of like get to a certain amount of coverage that we need. So that's like really, really good tool for everyone, but definitely have plans in the future. I think if anyone's been paying attention to what React Query and that stuff has been happening there, they've switched, to being a framework agnostic. Definitely something we're very interested in. We have like a vanilla.js core, which the React package uses, but it'd be great to be able to support other frameworks in the future, like Vue or Svelte. So yeah, keep on the lookout for that. Nothing soon, but yeah.
Well, the teaser is good enough. This is exciting. Well, I appreciate this, and I'm really happy that you're able to kind of talk about the library for the first time here. And it seems like a lot of what's going to happen in the future is probably closely related to our next talk, which is Rick Moo. And given you're going to get a preview of what's going to be possible in Ether's V6, you may want to stick around and also listen to what he's up to. So thank you so much, Tom. And without further ado, I'd like to welcome our last speaker of the day, and that is Richard Moore, talking about Ether's V6. Hi.
Hi, how goes?
Things are going great. How are you?
Excellent. Kind of just woke up, so.
That's a very familiar.
Exactly. I mean, it is almost 4 o'clock, so it makes sense.
All right. Well, great having you, Rick. Let's talk about V6 and see what things you can tell us without also committing to.
Excellent. Yes, let me find the keynote. Can you see that?
Everything is great.
Okie dokie. And the little bar for Zoom is covering up the button. There we go. Okay. So I was kind of expecting more Q&A at the end, so it might not be enough. So we'll figure that it was go along. But for those that don't know, Ethers is like, I don't know what the target audiences in terms of like familiarity with ethers, but it's just a library for interacting with the Ethereum blockchain and that sort of thing. So V6 is up and coming. I was hoping to have it out a while ago, but the beta is coming along, and I've got a big release I was hoping to make by this talk, but it didn't quite get finished last night. Hence waking up at 4. So a brief, there we go. So yes, one of the biggest features of V4 is I'm moving to modern ECMAScript or JavaScript features. Prior to like V5 and before, I only targeted features that were available in ES3. So it does mean that Ether's V5 will probably work in like Internet Explorer and like browsers circa 2010. But that's becoming less and less important, especially for Ethereum. And so moving to modern ES features gives us a lot of like really cool abilities that JavaScript's added in the last, 5 years. So one of the big ones that people seem to always want, and I am kind of looking forward to getting this out there, is big ints. Big ints are now built into JavaScript. I think it was like September 2000 that kind of the last holdout, which was Safari, added them. So everything should basically have access to big ints these days. There was a lot of issues like before using big number. There was a lot of extra command, like extra code you needed, because it was like .mol this, add that. You need to instantiate big numbers from their static constructor before you're doing anything with them. So nice thing with big ints is they're built into JavaScript. They just work. You just add this little n to the end of your number, and now you can have numbers that exceed the value that IEEE 754 can support. And it also means you can do other cool things, like you can just multiply them together. There's no complicated things you need to worry about that way. And you can just check them if they're equal to each other, use greater than, less than. I mean, that was a point of difficulty for a lot of people, especially when they're using test frameworks, and they just want to see if this one value is greater than another. And the existing frameworks just use like inequality operators internally. So lots of cool things that way. One kind of downfall of big ints, I'm still trying to figure out the best way around, is you can't JSON stringify them. And so I do expect some people have issues where they have a value they want, like a complicated structure they want to JSONify. And so there'll be a special function to help handle that sort of thing. But so that's big int. Another really cool feature, I mean, back in the day when I was using Python, this was just built into the language. ES6 proxies are freaking awesome. Basically, it is an object that if you're familiar in JavaScript, if you have an object and you call you call a method on it and that method doesn't exist, it just fails. The cool thing with the proxy is before that failure, it gives code a chance to determine, do I want to do something or do I just want to fail? And so if you have an object if you have object foo and you do foo.bar, if bar doesn't have a value, it'll just fail. But a proxy will give the code a chance to say, do you want to do anything with bar? And so in V6, one of the big things we do with this is contracts, because now contracts can take a property you're trying to access and kind of make it better educated guesses at what you're actually trying to do and find, for example, the method you want to call. If you're familiar with V5 and you've got like really complicated big ABIs from third parties, you probably also see like 1,000 warnings in your console log saying like duplicate API definitions, you have too many balanced ofs, you have too many owner ofs, because each one of these had a different signature, because Solidity allows you to overload signatures. So the cool thing is you only get those type of warnings now if you actually try using something that's ambiguous. And that kind of leads into, maybe it's a few slides ahead. I'll get to that in a second. But yes, basically it gets rid of all those errors that people have been receiving that were kind of required for ethers to throw up at the beginning because it wouldn't know whether you would try using them or not. Right, package exports, that's actually why the latest version's a little bit behind. I'm trying this out. Basically, in prior versions of Ether's V5, it was a massive mono repo with 20 some odd subpackages, and each subpackage is managed and has its own TS config and package JSON and all this crazy stuff. And it also meant that when you installed Ethers, some things would start getting out of sync. And if you blew away a bunch of stuff, but not everything, and then did an npm install, you start getting issues where versions of the library within Ethers, for example, Ethers project / provider, might not be compatible with the version of Ethers project / contracts you have. And so then you get all these really crazy warnings and errors that make no sense because it's basically just the build system's completely lost. And so you had to delete the package JSON or the package lock, your yarn locks, all those crazy things, delete the node modules, then do a fresh npm install, and things just worked. But it was a lot of hassle. So now using the new the package exports, it's just everything is in one package, Ethers. And if you do / providers, it knows to pull in a specific set of files. And so the big advantage that this really helps is it makes tooling much simpler. Tools are just much happier now with a normal build process. The original, like Ethers v5, has a convoluted, crazy build process to handle how TypeScript deals with composite packages, plus how the bundler munges all these things together. And so yes, bundler and tool support is much better. The other cool thing with this Ethers / provider thing is you still get all the great benefits of tree shaking, because the exports kind of steers the bundlers and steers the toolings as to what file to look at. And so because tree shaking really only works effectively on a per file level, these exports kind of guide the file processing part well. And right, basically publishing is much easier for me. Maintaining one package that I have to modify and not worry about having like 1,000 symlinks for, and then the symlinks sort of get like unsynchronized over time for one reason or another, or setting up a new machine. Anyways, it's just much easier. So I'm kind of blowing through my slides very quickly, and I'm a little bit worried I'm going to be too fast. Hopefully Kartik is thinking up some good questions for me or keeping track of things. Another big advantage of v5 is the dependencies. V6. I think v5 had dependencies around 9 or 10 dependencies. With this, we're down to 5 dependencies. The WebSocket library is only necessary in Node. I can't quite see on my slide. I think it was 60 million. But anyways, basically it's a very popular library that has a ton of downloads. So it's maintained. I feel like an important thing people don't look at when they look about dependencies, it's not just how many absolute dependencies you have, it's kind of how many different authors and contributors you're depending on because of those dependencies, and also the kind of like the quality of the author. When you see these packages have very few downloads, you almost have, I feel uncomfortable because it means that they're probably not worrying too much about the security. And all it takes is one of your dependencies to like fail, and all of a sudden the world is just lost. And we've seen things like the ESLint hack. I mean, there's always the possibility of supply chain hacks. So if we can reduce the number of people we have to rely on, but also increase the quality of the people we rely on, we help protect ourselves from all these supply chain problems. So TSLib, for example, I mean, it's only included in v6 because it drastically reduces the size of the library to include all those little helper methods that TypeScript injects for you once. But again, Microsoft is a fairly big company. If they got compromised, they would suffer some sort of like fallout and like PR nightmare. So they're heavily incentivized to keep all their security up and running. WS has a crazy number of downloads. It's only used in Node. I don't personally know the person, so I can't. That's my one kind of like concern. Paul Miller, the author of the Noble classes, he's awesome. They're all audited, and he's a big security guy as well. So, you know, we can kind of, I trust him more than I trust random other projects I've used in the past that maybe take a long time to get back to their like serious issues, that sort of thing. And then there's Ethers. If you're depending on Ethers, you're already depending on me being secure. And so my other library, AES.js, which Ethers uses, is kind of in the same security threat model. So anyways, the goal is to kind of like bring down dependencies, but also bring down the number of people that are responsible for those dependencies. That's kind of my take on that. Okay, now back onto like more cool v6 things. So this goes back to the proxy thing I mentioned earlier. Because the proxy can kind of decide at runtime, we get all these cool abilities. The next two slides will cover those. So first of all, we have a typed contract interaction. Historically, if you saw this ABI, as you can see, there's two methods called foo. Sorry. Yes, as you can see, we have two methods called foo. So first of all, in v5, if you load this ABI app, you'll get warnings in your console saying duplicate definitions of foo, which makes sense. There are two of them. And so if you just did contract.foo, as you can see in this first case, it doesn't know which one you actually meant to call, because a address can also look like a number. So in the first case, it would still fail as it does in v5. But in v6, we added the typed object. And so typed lets you kind of hint to the contract, by the way, this sum adder parameter is actually an address. And now it's no longer ambiguous. It knows that if you're calling foo and the first value is something, but the second value has to be an address, then it can find the right foo to call. And keyword contract interaction. So this is something that I've just started adding. So it's still very bleeding edge. But this is a feature that I've seen a few people ask for. They want to be able to basically call a contract method using the keyed arguments. Like this is something you're probably familiar with, the KW args. If you're using Python, excuse me, it can make code a little more readable in many situations. And so if you pass in one of these typed keywords objects, it realizes that all the parameters are not being passed in positionally. They're not being passed in based on the order of the parameters as they show up in the ABI, but actually by their name. And so, for example, in this example, you see I'm using from, to, and value, but the order doesn't really matter. If you wanted to, you could specify the to and the from, and then the value. You could imagine constructing these objects somewhere else. If this is available, throw that in, and kind of like codifying or procedurally generating this stuff. And so this will also be useful for a lot of like frameworks that need to kind of call functions in a constructive way based on other information they may be pulling from other places. Is there anything else to say on that? So I think that's good for now. Right, so another big thing that's changed in v6 is how providers work. So not how they work from users' points of view, but how they work internally. When v5 came out, it was very heavily influenced by v4, which was heavily influenced by v3, and so on and so on. So back in like 2017, it was a very different landscape. Basically, everyone only used HTTP providers. The socket providers were still kind of like a niche thing. WebSockets were expensive to run. Now there's a much more it's much more common to use WebSockets, and even IPC. I don't think IPC is still that popular, but the thing is, once you support one, you might as well support both because they're both basically the same. So there's been a lot of work just to abstract and change the model so that internally they work better from a long-lived socket connection. So, for example, WebSockets. As a result, one thing people always want with WebSockets is they want it that when there's a hiccup, when the connection drops, they want the WebSocket to reconnect and just continue on trucking. It's actually quite difficult to do, especially in how v5 was structured, because you could imagine if you were streaming, if you were listening for some event and then there was a hang up and you reconnect, you may have missed events during that time. You need to kind of know which was the last event you saw, so you can kind of resubscribe to old events or pull for the old events and replay those, but you can't start emitting the new events till the old events are processed because you still want to keep things in order. Basically, there's just, it's a consistency nightmare. So in v6, there's been a change in how the overall model works so that these are all abstracted away. So each provider kind of gets to decide how it's going to process these. And so the WebSocket provider has its own custom mojo thing going on so that it knows how to reconnect, restart, and kind of keep all the events consistent. On that note, crap, I've lost track of where I was going with that. Oh yes, pausing. That was the other cool thing. I think that might actually be on another slide though. Maybe I'll save that for the next slide. I think it's there. So great. Basically, by using filter IDs, we also gain a lot of abilities because now we can actually get orphaned events from even a polling connection. Some backends do not support filter ID, but things like Infera do, and so we can use those, which also helps some of the problems with talking to a large backend cluster of nodes, making sure that everything comes in consistently and in order. Also, there's new plugins available so that, for example, it's much easier if you're trying to build something on top of AWS, which might want bearer authentication tokens, and generalized contract runner type. This is a little bit of a, I'll try giving a quick overview. Basically, a contract runner is something you pass into a contract to run it. Historically in V5, that's been either a provider, a signer, or null. And depending what you pass in kind of dictates what type of things you can use the contract for. By generalizing the contract runner, there's now a higher level interface that anything can implement. It happens that provider implements this interface. It happens that signer implements this interface. The cool thing is you can now build your own random weird things that also implement this interface, which gives you, for example, some really cool things you could do for mocking purposes. If you want to build some sort of test contract runner that's going to feed fake data, but that's meaningful to the contract if it asks for it, and it'll think it's just talking to something speaking its language. Right, here's the pausing thing I was mentioning. So basically, providers can now be paused. You can pause, resume, restart them. And so this was kind of almost free because we needed this functionality for the purposes of being able to restart a WebSocket provider, like the events on it, and make sure everything comes back consistently. So this is an example where if your application goes in the background, if they click a different tab in the browser, you might as well turn off all of the providers that are running events and triggering things and updating the UI, because you're using bandwidth, you're paying for those inferior requests or Alchemy or Anchor, you're paying for, or even like just contacting your own server to do things, you're paying for that infrastructure. You might as well pause it when you're not being used. Maybe they close the tab later, and then anything you were updating wouldn't have mattered anyways. Or when they come back later, you can then decide, do I want to continue replaying all the events that happened while my tab was gone? Do I want to just replay the last 10 minutes to catch up my UI so it looks nice, or just delete the state? So I think this will help a lot of people as well. It makes it nice and easy to pause a provider. Network plugins. So another big issue with ethers is some people want to use ethers on networks, chains that are kind of insane. Like they just break the rules in ways that made either no sense for them to break, or in ways that, from my perspective as a Ethereum semi-maximalist, didn't really think was a great idea. But I also don't want to preclude those people from having access to ethers. I don't want them building their whole own other library that maybe has other problems, or I mean, in general, it's just nice if we all work together, and that way anything they build on top of ethers, other Ethereum people can use as well. And so network plugins kind of allow weird networks to be weird, and just treat it as that's an okay thing to be. So for example, some examples I will give of this are cross-chain ENS support. ENS actually supports any chain in the universe you want. ENS supports it. The problem is you need an Ethereum connection for that, for a lot of networks. So for example, if you are on Binance Smart Chain and you want to get a Binance Smart Chain address, you need some way to talk to L1 Ethereum to ask for that. So this just kind of provides a way for networks to figure out how to connect to and talk to L1 chains. Different chains have their own way of computing intrinsic gas costs. That's not really that interesting for most people. That's just something kind of used internally by contracts when they're trying to estimate gas. So for example, in terms of EIP 1559 priority fees, the Mumbai, what's that one? Polygon. The Polygon peeps kind of chose weird values for those, and it causes a lot of confusion when people use ethers, because the way they use the IP 1559 is not really the way that 1559 was intended to be used, and it's certainly not the way it works on Ethereum. And so this allows people to build and just kind of attach a little plugin to their network saying, by the way, when doing gas estimation, use this other criteria to kind of like munge the values. It also lets you add extra fields or missing fields to the transaction. There are some chains that actually compute transaction hashes completely differently. This makes it nice and easy for them to kind of shim that in there without having to have their own complete instance of every provider under the sun. And it also allows you having custom URLs because in general, I try keeping ethers quite lean, which means focusing on kind of the main chains people use. But for example, Etherscan does have a Binance Smart Chain API. And so this means that the network object can now encode that, so that if anybody wants to use Binance Smart Chain with ethers, they just need that one network object. And once they pass it into a provider, the provider knows all those weird exceptions. Excellent. And I think I made it through. And I guess I took longer than I thought I might. But yes, that's V6 in a nutshell from what I could throw slides together in the last few days for. So
that was still great. And all right, so I have a few questions, but they're largely meta questions because you were very concise and articulate on what you're trying to do, and it's very very easy to understand like what this does and why you're doing it. I think maybe kind of just let's start with like the more obvious one. Obviously didn't get deployed today, but what's the timeline on
yeah.
When should we see V6 coming out?
So there is already V6 beta. It's been out for a few months now. So if anybody wants to use it, just npm install ethers at v6-beta. The exports stuff is kind of new. I just found out kind of that it was widely supported by most of the tools I need this week. So I started porting everything over to use that.
Oh, sorry, I ended up disabling the screen share in case I didn't realize.
Okay.
You're more than welcome to.
Oh, there we go. Okay, I thought maybe my device had hung up on you. Right. So I only discovered like this week that it's widely supported. So I've been kind of like adding that. So that was what I was hoping to get out today. It didn't quite happen. But hopefully this weekend, people will be able to start using the new version that has the package exports. But yes, it's already available. It's on GitHub. If you go to GitHub and look at the branches, there's a branch called V6-beta. And the new one that will be coming will be V6-beta-exports. That's the one that will include the exports instead of the crazy monorepo. The monorepo still isn't completely off the table. I'm just hoping it is, because the exports is so much more useful and so much easier to develop against.
Tree shaking is way nicer. Okay, so other set of questions. Broadly kind of speaking, and these are kind of mostly meta questions, but like I like the inference piece. I like how you're trying to conform ES6 to Python. And the network plugin, or just plug. Oh, actually, maybe one. Yeah. So I like the network plugin architecture. Like sounds really actually extensible, and this is how you get it to apply to other EVM chains. Is it just specifically for network plugins, or is it overall just a hook system that you were talking about, but you just refer to the network plugins as the example?
So there's two places I kind of put plugins. One was in the provider, one was in the network. It is mostly just to handle kind of exceptional cases for now. They are hooks things, and I mean, once people have hooks, they'll use them in weird and crazy ways, and it'll be awesome. And I'm looking forward to that. But the main purpose that I'm putting them in for is just kind of like for headache reduction. When people have some weird network and they're like, this thing's not working for me, and I have to give them like this big workaround, or they have to like re-implement this whole thing. It'll be easier if I can just say like, just hijack this hook on the network, or add this hook on this network, and then the provider will kind of know what you will need to do. The other thing is it's also extensible, that if some one of these weird networks comes along and has something that I don't support, it doesn't need to change the API for the provider, because I can basically add the special logic into the provider necessary. They can add the plugin onto the network, and then when the provider is running, it can ask the network for this new plugin that didn't exist before, and kind of go from there. So it just means that I can stop changing interfaces, like the signatures for methods, because someone has some new thing. Like historically, I haven't been able to. I don't backwards breaking changes. So they say, I want to do this thing, and I'm just like, I'm sorry, but there's nothing I can do about it because it'll break. You know, there's almost 1 million downloads a week now of this thing. It's going to break a ton of people if I just make this weird change for you. So it gives me the ability to still make weird changes for people who need weird changes without hurting everyone else.
That's amazing. On to the meta questions. How do you decide when something is ready for release and which features should be part of a major version upgrade versus like a minor or testing? Like what's kind of been the design or philosophy behind this thing? Because V6 has been in the works for quite some time. How do you get to a new version?
Exactly. It's very, I mean, it's very much an art. It's very like, I remember I think it was 8 months into V5 when I first told some people like, oh, I've got some really cool ideas I want to do for V6. Here's what I'm going to do. And everyone was like, 8 months, it's too soon. And so I kind of like, I just kind of started wrapping more and more ideas in until eventually got away from me. And then it was like, it was no longer something I could complete in a short period of time. And so that's why it's like 2 years later since V5 has come out. So I think in the future, I'm going to be a little more aggressive, trying to release more frequently in terms of major versions. In terms of minor versions are required anytime that you're breaking kind of forwards compatibility, and patches are just nothing bad is changing. But it's not an easy thing to do, and even trying to figure out what features to include. So for example, if I was willing to wait another 6 months, because right now there's still a bunch of craziness involved for fetch. Fetch is in the browser. Fetch happens to now be in Node 18. Yep. If I decided to cut Node 14 and Node 16 out, all of a sudden my life become much easier. Or if I waited 6 months for Node 18 to kind of, but the thing is, you kind of have to, it's like buying a new computer, right? Like my dad's been trying to buy this new computer, and he keeps, every time he has enough money to buy a new one, he's like, oh, but if I wait another 3 months, it's gonna be so much better. It's like, but you have to kind of find that happy balance between like the pragmatic side and the,
if your core principle is like preserving backwards compatibility, then I feel like you have to kind of deal with the polyfills for quite some time.
Exactly. And for me, backwards compatibility is an important feature. And this is something that a lot of people do not really get. They're like, well, why don't you just do this? Why don't you just drop support for that? Like, I'm the maintainer of so many legacy like iPhone apps and these sorts of things. When these things like drop compatibility, it breaks, like it's just a week of my life that disappears now, because somebody dropped support for one little thing, and that little thing was used by some other little thing I used. And like I said, it's turtles all the way down. The dependency tree goes right down to the floor. That bottomest dependency is borked, and now you're borked. So, yeah.
I hope the WebSocket library is not using LeftPad. And all right, so 2 more questions. One is, how do you, granted, obviously so much of, I would say Web3 infra right now relies on ethers. How do you kind of look at how people are using the library, or how people are using other abstractions that use the library? We just talked about LogMe just before this, and kind of see how it's being implemented versus what you think you can help simplify and abstract for others. Do you kind of care about that? How often do you actually do these things, and how often those decisions end up influencing features? And sort of what's the process like there? And then I'll close off with a simpler question. And
cool. Yeah, I mean, I absolutely love other things using it. It's really cool. I mean, I just saw the last few minutes of the WogMe thing, and I was really impressed by the way it was able to detect errors. And I was just like, man, I feel like it's really cool to see all these things built on top of ethers that extend it, because it means that it's something I don't have to write. Because the reason I made ethers in the first place is I made ethers for me. Even today, ethers is largely for me. It just happens that I make it available for other people as well. And so all these other things I see out there for it are awesome, because it now means that I have this extra ability using my own library that, I mean, going back, you can even imagine like syntax highlighters. Like writing a syntax highlighter is like boring and annoying. If somebody else out there wants to write them for me and let me use them, like it's awesome. So yeah, I mean, that's one of the big things as well I'm seeing with that's one of the reasons why I want things like the typed the keywords
Inference.
type thing. Exactly. Like, I basically want keywords to be available so people who are building frameworks can continue building frameworks that kind of expand and enhance the capabilities of ethers, because that way someday I can use those frameworks and save myself time and effort. And if it makes things more secure and better for them, like, why not? Because, and this is one of the things I find in common when you build nice abstract libraries, you'll often find a feature you add that's like increases abstraction. It makes it easier for frameworks to interact with your stuff, makes it easier for you when you need to interact with your stuff sometimes, because you often do have these very abstract, high-level ways you end up needing to interact with things, and having already abstracted them for the frameworks to make it easy for code to operate with it, it makes it easier for you to write your own code that operates with it, if that makes sense.
Yeah, it does. I think abstraction is also an art, and you end up learning about kind of how, in a way, these things are codependent. So as long as that helps you, anyone from improve it to make your life easier in the future, that's a pretty good way to look at it. Final question. How do you usually collaborate with open source contributions on the project? And if somebody wants to get involved, how can they contribute to Ethers?
So I wasn't sure if your first part of the question is that with external partners or?
Oh, sorry, external contributions. So just on the GitHub, when you are complaining or suggesting or submitting pull requests, like what's kind of the process and how can they get more involved if they would like to?
Absolutely. So generally I prefer, I mean, well, that's one of the things I'm trying to change with the V6. I'm trying to be less megalomaniacal. But I've historically been very tight with my code, and I don't like other people just modifying it. So I actually usually prefer, like, there's definitely PRs I appreciate. The PR concisely shows the problem, but I still usually make those changes myself. There are weird like attack vectors from just merging PRs, so I merge them manually. There's actually Git POAP. I should give them a shout out as well. I'll be announcing, they've integrated with Ethers because Ethers has its own process, because Ethers doesn't really merge PRs. It kind of, the PRs I examine and I merge manually, but now I've got a script that runs, and anyone who has been tagged in one of my commits for either a PR or an issue, I really love issues as well. If someone wants to open an issue and say, rather than building a PR, because a PR is actually quite a bit of effort, but if you've identified the problem is like, oh, in line 37 of this thing, it's a plus, or it's a less than or equal to, which should be just less than. Like just a quick example of that sort of thing. It's something that I can change very quickly and easily, make and then push the fix out for. And I tag all my commits with issue numbers and that sort of thing. So the cool thing is the script now just picks up the fact that you reported the bug. You don't have to fix the bug. You just have to report the bug. If you reported it and it gets tagged, so don't just report bugs, because if you just open up and report a bunch of spam, it's not going to count. It's only for ones that actually get tagged as solving something. But they get added to the contributors file, and the contributors file has a JSON equivalent, which is then fed to Git POAP, and they can use that to like issue a POAP. I always call it POAP. I don't know how to pronounce the thing. The POAP.
I say POAP too.
Okay, yes, exactly. So there we go. So yeah, it'll issue you a POAP. And so basically, yeah, I mean, I'm always open for, if you have a question, please use discussions. If you have an idea, discussions also has an ideas thing. If there's enhancements, you can jump right to that. But usually I'd recommend starting a discussion on GitHub about a new idea before jumping to the enhancement. But basically, I do everything through GitHub. Everything is an issue. Everything is a discussion or a PR. I also listen to Twitter. If people want to tweet out to me, it's @rickmoo. I do keep in mind, so there's definitely climate-y issue things we have to worry about. So I do keep a complete synced copy of all of my GitHub discussions, issues, et cetera, locally, so that if there ever is like a tornado cache like event against Ethers for whatever reason, then I have some way to at least mirror a lot of that data. But for now, basically everything goes through GitHub, and any aspect of decentralization happens on my side on a private clone of all that data. So
awesome. That was great. Well, thank you so much. And can't wait for V6 to come out very soon.
Excellent. Thanks.
All right. That was Rick Moo talking about a preview to V6. And with that, we are at a wrap for our DevTools Summit. So thank you everybody for tuning in. Thank you to all the hackers that got excited about what's going to happen for the next few weeks and what you can do to simplify your life on the developer side. And with that, happy hacking, everybody, and we'll see you all on Discord. And until the next week's summit, take care and goodbye and enjoy some lo-fi beats. See you, everybody.